Algebra is a language. In many ways, mastering algebra is just like learning French, Tamil, or Italian, or maybe even Japanese. To understand algebra, you need to learn how to read it and how to change plain English into math talk and math talk back into plain English. And some people call it as puzzle. Yes, with algebra, you get to find secret things. And when you learn some of the tricks, algebra becomes a fun challenge to work out how to solve your skills in solving each question. Okay, let's start with your puzzle. What is the missing number here? The answer is 8, right? Because 8 minus 3 equals 5. Easy stuff. Well, in algebra we don't use blank boxes. We use a letter, usually an X, Y or Z. But any letter is fine. So we write x minus 3 equals 5. It is really that simple. The letter in this case, an X, just means we don't know this yet and is often called the unknown or the variable or letter. And in algebra, a constant is a number on its own. Like fixed values here, -3 and 5 are constants. And when we solve this, x minus 3 equals 5, we write x equals 8. We can understand from that, oftentimes algebra substitute letters or variables for unknown values. That's why I said in the beginning, algebra is good to find secret things. But what is the real benefit of using variables? Before answering the question, read the short story. A man was carrying balloons, but the wind blew 4 of them away. He only has 9 balloons left. How many did he start with? Well, this question has a bunch of words in it. Let's see if we can cut the question down a little. Consider a scenario where a man is carrying X balloons. The wind blew 4 of his balloons away. So, we subtract 4 from X. In the end, this man had 9 balloons. The total amount will then be 9. All we have to do now is find X. This is how the entire question can be written. So absolutely, the use of algebra simplifies our daily tasks. Hi, let's learn about the types of numbers. Imagine a scenario where two people, a father and his 4-year-old son. Son is exploring the world for the very first time with his father by walking along the road.
Dad, how many floors are there in the apartment?
There are 7 floors in that apartment, my dear.
How deep is this well?
It would be 6 meters deep.
Dad, how tall is the tree?
That tree may be 6 meters.
Dad, what is the time right now?
It's 8 o'clock.
Dad, I want ice cream.
Oops, I have no money, my dear. Actually, I forgot to bring my wallet from home. I will buy it next time.
Okay, Dad. Dad, how much temperature is there now?
I think there would be minus 20 degrees Celsius. In Japan, people speak Japanese. If people speak Japanese in France, French people may not understand. So on the whole, I don't understand what they both are saying. To avoid this confusion in science, mathematicians discover a universal language that is called mathematics. In our previous scenario, son asked his father some questions which are: how many floors are there in the apartment? What is the time? And how tall is that tree? For that his father replied, 7 floors, 8 o'clock and 6 meters. He counted them naturally. So that's the name of natural numbers or counting numbers because that we used to count. And it's typically denoted by the symbol, the stylish n. But at certain point, father replied, I have no money, nothing. Mathematically we call this term nothing is 0. Well, the natural number with this additional number 0 became whole numbers and it's denoted by the stylish w. This is the place I have a doubt. When son asked his father how tall is the tree, father replied 6 meters. At the same time, son asked how deep is this well, he replied the same answer to that, 6 meters. This was why I doubted. How come there is only one natural number to those two different situations? Because tall means going up, whereas deep means going down. How to differentiate these two things? That's why whatever naturally appear like height, much, fast, consider them as positive numbers. Whereas depth, little, late, consider them as negative numbers. Now let's look at them in a number line. The point 0 on the number line is the origin. Numbers to the right of 0 are positive and numbers to the left of 0 are negative. The term non-negative describes a number that is either positive or 0. Okay, for every positive number, there is a negative number. Negative numbers can also be thought of as the opposite of a positive number. So the opposite of 5 is negative 5. You might also notice that as we go further down the number line, the negative numbers appear to get larger. However, the numbers are really getting smaller. For example, negative 10 is smaller than negative 5. This can be confusing, but think about it in terms of temperature. Suppose on a winter's day, it's negative 30 degrees Celsius in Prospect Creek, Alaska, and negative 40 degrees Celsius in Yakutia, Siberia. Yakutia would be colder than Prospect Creek because negative 40 is lower than negative 30. Okay, if we join the negative numbers with the whole number, we call it as integers. And it is denoted by z. Z? Yes, it is because the German word for numbers is Zahlen. The integers form a pretty comprehensive set of numbers, right? But even after coining integers, one could not relax. We can add integers, subtract integers, and multiply integers. Only when we want to divide two integers, it doesn't always work. The ratio 10 over 2 is simple. 8 over 2 is also simple. But 9 over 2 is not quite as obvious. It has to be somewhere in between 4 and 5. But unfortunately, there are not any integers between 4 and 5. Therefore, 9 over 2 must belong to a new group of numbers. These are called quotients or rational numbers. Since a ratio made by dividing an integer by another integer, the term rational contains the word ratio, and a ratio is the same as a fraction. So that can help you remember what a rational number is. And the rational number is represented by the symbol q. So all fractions or ratios such as 376 over 290, this or this are rational numbers. Even integers, let's say negative 7. This number can be written as a rational number, namely negative 7 divided by 1. So all integers are rational numbers too. And obviously the whole numbers and the natural numbers are also rational numbers. Rational numbers usually have many representations. For example, 1 over 2 equals 2 over 4 equals 3 over 6 and so on. In addition, They can be written as decimal numbers such as 1 over 2 equal 0.5 or 1 over 3 equals 0.33333 and so on. So the decimal expansion of rational numbers is either finite like 0.64 or it eventually consists of repeating blocks of digits like 0.92, 75, 75, 75 and so on. So, formally speaking, we can see that rational numbers can be expressed as a terminating or repeating. Or we can say a rational number is a number that can be in the form of p divided by q, where p and q are integers and q is not equal to 0. Why? We will see why we should not divide by 0 in the next video. Rational numbers are everywhere along the number line. However close you look, there will be millions and millions more. Surely there is no space left for any other numbers. But unfortunately, this assumption is wrong. And you know, there are decimal numbers that don't repeat and don't end are called irrational numbers. You have probably heard of pi. Pi? What is pi? Okay, I will explain. Well, this question is one that people have puzzled over for thousands of years. Early mathematicians noticed that there is a special relationship between a circle's circumference, the distance around its edge, and its diameter, the distance across the circle through its center. If we take a circle of any size and divide its circumference by its diameter, you will always get the same number, pi. Pi is often rounded to 22 over 7 or 3.14, but in reality, those are just approximations. Actually, pi is 3.14159265 and so on. The decimal goes on like that forever, without stopping and without repeating a pattern. That's why ancient Greek mathematicians represented it with a letter from their alphabet, because there is no way to write the full number. At least theoretically, pi can be written as a decimal, but not a fraction or rational, so that it is called an irrational number. Like pi, there are other famous irrational numbers in mathematics: Euler number, golden number, square root of 2, and so on. And there is a special name for combination of rational and irrational numbers, that is real numbers. And it is denoted by R. And that's it. That's all of the most important number types in mathematics. From the natural numbers through to the real numbers. There are other types of numbers because mathematics is a broad subject. We will see them later. Summary. To put your new knowledge into practice, try the your turn questions below. Y divided by 0 is undefined. Let me answer this question with a real life situation. Imagine a scenario where two people, Sam and Adam. Sam borrowed $10 from Adam and promised him, I will give you $2 each day tomorrow onwards. If I ask you, as far as Sam promise is concerned, in how many days Sam will give all the $10 to Adam? 5 days. Easy stuff, innit? By the way, there are several ways to answer this question. One among them, the total $10 divided by 2 installments equals 5 days. Imagine a similar scenario. This time Sam borrowed $200 from Adam and promised him, I will give you $0 each day tomorrow onwards. Yeah, $0.
If I ask you in how many days Sam will give all the $200 to Adam by giving $0. Actually, there is no zero currency exists in this world, which means Sam is absolutely cheating Adam. Mathematically, we call it as undefined. So the bottom of the line, if we divide any number by 0, it cannot be defined. Absolutely, you cannot define that. Just like cheating.
Hi, let's learn about the identity law. Identity law says that return the input unchanged, like 0 and 1, because adding 0 to any number doesn't change it. At the same time, multiplying any number by 1 leaves it unchanged. That's why 0 is additive identity and 1 is multiplicative identity. The word identity is defined as the state or fact of remaining the same. Example: the identity of the fingerprints at the crime scene helped catch the burglar. Try to remember the I in the word identity. Certain variables can have an attitude such as, I am the most important thing in the world and I do not want to change. The identity element allows the variable to maintain this attitude and remain the same.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the commutative laws. The law says that we can swap numbers over and still get the same answer when we add or when we multiply. Here we see the 3 plus 5 equals 5 plus 3. See how the numbers travel back and forth like a commuter? So we say addition is commutative. It works for other numbers too. So we get this law: a plus b equals b plus a. Here we can see that 2 times 4 equals 4 times 2. It also works for other numbers. So we get this law: a times b equals b times a. Uses. Sometimes it is easier to add or multiply in different order. For example, what is 12% of 50? We can write this mathematically as 12% times 50. Because multiplication is commutative, we can swap over 12 and 50. So 50% times 12. So what this means here is that 12% of 50 is actually equal to 50% of 12. And 50% is much easier to calculate because that is just half of the number. So 50% of 12 is 6. And that means 12% of 50 is also 6. Using the same idea, let's solve this one. We can write this mathematically as 37% times 200. Because multiplication is commutative, we can swap over 37 and 200. Now we have to think little bit more about this one. But 200% of a number just means 2 times that number. Because 100% is one of the whole thing. So 200% means 2 of those things. So here If we want 37% of 200, that's 200% of 37, which is just 2 times 37, which equals 74. But don't go too far. The commutative law does not work for division. Here, 18 divided by 3 equals 6. But 3 divided by 18 equals 1 by 6. Summary. To put your new knowledge into practice, try the your turn questions below. We all know that how to multiply positive numbers. But what happens when we multiply negative numbers? With the invention of negative numbers, the rules of multiplication had to be expanded to allow the numbers to be either positive or negative. The multiplication rules were chosen to keep everything consistent. Example: since 1 is the multiplicative identity, if a number is multiplied by 1, we should expect that the number's value and the sign will not change. Therefore, multiplying a positive number times a positive number must yield a positive result. And multiplying a positive number times a negative number must yield a negative result. Because of the commutative property of multiplication, we should be able to swap the numbers and get the same result. So if either number is negative, we must still get a negative result. But what if both numbers are negative? If two negative numbers are multiplied, should the product be positive or negative? Let me answer this question with an example. Here, as you can see, there are two colors of balls. Every green ball represents positive 1 and every red ball represents negative 1. Let's say I add in 2 green balls into the box. So my box is worth 2 at this moment. And if I add in 1 red ball, as we know the positive 1 and negative 1 are opposite to each other, we can cancel them out. So my box right now is worth positive 1. We can write this scenario mathematically as, firstly I added 2 green balls and then I added 1 red ball. Generally, in mathematics, we should not write more than one sign back to back like this. We have to separate them with a bracket or parenthesis, which is another form of multiplication. So, the worth inside the box is positive 1. Okay, this time, I put in 4 green balls and 3 red balls. We can cancel out every red ball for every green ball. So, the balls are left in the box after cancel is positive 1. We can write this scenario mathematically like this. Okay, at this moment, my box worth is positive 1. Now just imagine what happens if I take away one of these red balls from the box. I can write this as, if I take away, take away means subtraction. So if I take away one of the red balls from the box, again, we should not write more than one sign back to back like this. We have to separate them with a bracket or parenthesis. So if I take away one of the red balls from the box, then the leftover in the box will be positive 2. So 1 negative multiplied by negative 1 is 2. From here, we can get the answer to the question that I asked, what if two negatives are multiplied? Here this equation must be true only if negative multiplied by negative is positive. Now we know what sign the result should be when we multiply two numbers of any sign. Multiplying two numbers with the same sign always gives a positive result. And multiplying two numbers with opposite signs always gives a negative result. Understanding this can help us simplify multiplication problems involving multiple numbers of different signs. Let's say that we have a bunch of positive and negative numbers which are multiplied. The commutative property of multiplication says that we can arrange these numbers in any way we like. So let's group pairs of negative numbers together. Each pair of negative numbers creates the same result as if the pair was positive. So we can change their signs to positive without changing the result of the multiplication. Since there was an even number of negative numbers, after each pair of negatives was changed to positives, there were no negative numbers left over. Therefore, the result of the multiplication is positive. Now let's see what happens if we have an odd number of negative numbers. Once again, we group the negative numbers into pairs and change their signs. But one unpaired negative number is left. So this time, the result of the multiplication is negative. Here is another interesting trick which can come in handy. Multiplying any positive number, which we call a, by negative 1 switches its sign to negative. Likewise, multiplying any negative number by negative 1 will switch its sign to positive.
Summary. To put your new knowledge into practice, try the your turn questions below. Hi, let's learn about the inverse properties. In mathematics, there are four basic arithmetic operations, which are addition, multiplication, subtraction, and division. Of these, addition and multiplication are two primary operations. Subtraction and division are the inverse operation of addition and multiplication respectively. Inverse means the opposite in effect, the reverse of. It's a general idea in mathematics and has many meanings. Here are a few. Adding moves us one way, subtracting moves us the opposite way. Example, 3 plus 4 equals 7 can be reversed by 7 minus 4 equals 3. Back to where we started. And the other way around, 6 minus 5 equals 1 can be reversed by 1 plus 5 equals 6. Back to where we started again. The additive inverse is what we add to a number to get 0. For example, the additive inverse of minus 5 is plus 5 because minus 5 plus 5 equals 0. It works for other numbers too. So we get this property. Minus a plus a equals 0. Multiplying can be undone by dividing. Example, 2 multiplied by 3 equals 6 can be reversed by 6 divided by 3 equals 2. Back to where we started. It works the other way around too. Dividing can be undone by multiplying. 12 divided by 4 equals 3 can be reversed by 3 multiplied by 4 equals 12. Back to where we started again. The multiplicative inverse is what we multiply a number by to get 1. It is the reciprocal of a number. Example, the multiplicative inverse of 5 is 1 by 5. Because 5 multiplied by 1 by 5 equals 1. It works for other numbers too. But not with 0. We cannot divide it by 0. For example, 6 multiplied by 0 equals 0. But 0 divided by 0 is not 6. So we get this property. A multiplied by 1 by A equals 1, where A should not be equal to 0. Summary. To put your new knowledge into practice, try the your turn questions below.
This is a short video on the different ways to write multiplication and the different ways you can possibly see them in your problems. So this video should hopefully clear up the confusions when you are dealing multiplication with addition and subtraction. So the first thing we need to know, there are 4 ways that we can indicate multiplication. The traditional sign, this little x symbol here meaning times or multiply. So we can say 4 times 2 or 4 multiplied by 2, which we know is 8. We have this solid dot, 3 times 5 is going to be equal to 15. This also indicates multiplication. And another way to write it is to use parentheses or brackets. 2 numbers sitting next to each other, 1 in bracket or 2 in brackets, it doesn't matter. Both of these indicate multiplications. So 6 times 5 is 30 or 3 times negative 6 is negative 18. Since 3 is really positive 3 and a positive times a negative is a negative 18. And finally, if you put the number next to the letter, it will mean multiply. So 5x means 5 times x. Since the x look like the multiplication symbol, that can be very confusing. So in algebra, we don't use the multiply symbol between numbers and letters. So these are all multiplication symbols. The important thing to remember is that if there is no addition or subtraction in between the numbers, then the operation is multiplication. Now let's take a look at some more complicated. We can see from this example that we include some addition and subtraction signs, and we have some numbers that are multiplied together. In mathematics, there is an order that do multiply before add and subtract. To more details on that, watch order of operations video. So here first, what you do is multiply the numbers wherever you can before add and subtract. So I am going to mark the numbers wherever I can multiply. So here we have 8 and then negative 6 times 2. So we know this is going to be multiplication here. Then we have positive 5 times negative 1. This is going to be multiplication. And then we have negative 7 times negative 3. This is also going to be a multiplication. As you can see now, we have marked the numbers, we have indicated the multiplication. Let's start simplify now. Always go from left to right. So I'm gonna write 8 as it is, because I should not subtract this with 6 before multiplication process over. Okay, then negative 6 times 2 is negative 12. Since a negative times a positive is a negative and a 6 times 2 is 12. And likewise, 5 times negative 1 is negative 5. Then we have negative 7 times negative 3 is positive 21. Since a negative times a negative is a positive and 7 times 3 is 21. Now at this point, we can add all of our positive numbers together and then add all of our negative numbers together and get our final result. So here positive numbers we have 8 and 21. Since a number has no sign, it usually means that it is a positive number. Just 8 is really positive 8. So I write 8 plus 21 here. The negative numbers are negative 12 and negative 5. So we have 8 plus 21 is 29 and negative 12 negative 5 is negative 17. Therefore, 29 minus 17 is 12. Now let's look at our second example here. Firstly, we are going to again mark our multiplication. So here we have 3 times 2 indicated with a solid dot. So we know this is going to be multiplication here. Then we have negative 5 times 7 indicated with the traditional sign. So this is going to be a multiplication. And then we have a minus 4. Then a plus 6 times 2. So again multiplication here. As you can see now, we have marked the numbers. We have indicated the multiplication. Let's start simplify now. Remember, always go from left to right. So 3 times 2 gives us 6. Then negative 5 times 7 gives us negative 35. Since a negative times a positive is a negative and 5 times 7 is 35. And I'm gonna copy minus 4 which I didn't use. Then we have plus 6 times 2 gives us plus 12. Now we can do the same thing we did it before. We add up all of our positive numbers and then add up all of our negative numbers. Or we can just do the addition and subtraction together moving from left to right. So 6 minus 35 is minus 29. That minus 29 minus 4 is minus 33. And that minus 33 plus 12 is minus 21. That's it. Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the order of operations. Operations mean things like addition, subtraction, multiplication, division, exponents, and so on. When you see something like this, what part should you calculate first? Whether start at the left and go to the right or go from right to left. When we calculate them in wrong order, we can get a wrong answer. So, long ago, mathematicians agreed to follow rules when doing calculations, and they are order of operations. First, brackets. Let's do things in brackets first. So, 3 times 9 equals 27. If I do multiplication first, we get 3 times 5, that is 15 plus 4, which equals 19. Second, exponents. Before multiply, divide, add or subtract. Exponents are like squaring, roots, etc. Don't worry, we will learn about exponents in detail later. Here, we have to square the 3 before multiply with 6. 3 square is nothing but 3 times 3, which is 9. So we get 6 times 9, which equals 54. On the other side, if I multiply 6 with 3 first, we get 18 square. 18 square means 18 times 18, which is 324. Third, multiply or divide before you add or subtract. Here, if I multiply 3 with 5, before I add with 6, we get 6 plus 15, which equals 21. Whereas if I add 3 with 6 before multiply with 5, we get 9 times 5 equals 45. What if division and multiplication exist? In that case, just go left to right. Here, if I divide 20 by 5 before I multiply 5 with 2, we get 4 times 2, which equals 8. Whereas, if I multiply 5 with 2 before I cancel 5 with 20, we get 20 divided by 10, which equals 2. And finally, what about the example from the beginning? Brackets first, in which do exponents. Then multiply. Then add. Brackets completed. Last operation is a subtract. Summary.
More examples. So this should hopefully clear up the confusions when you're dealing too many operations at a time. Okay, first one. How do you work out 5 plus 6 times 2 minus 8? We know that we have to do multiplication before addition and subtraction. Remember BEDMAS, where the letter M comes first before A and S. So first, 6 times 2, which equals 12. The thing is, just copy others. Write others as it is from left side to right side. It helps us avoid mistakes. So we have 5 plus 12 minus 8. We have two operations right now. One is addition, another one is subtraction. Well, add and subtract rank equally. So just go left to right. 5 plus 12 is 17. And that 17 minus 8 is 9. That's it. Now let's try this one. Here, as you can see, there are many operations. Though the items inside brackets or parentheses come first in the order of operations. You do the stuff inside the bracket before anything else. Okay, in the bracket, we have two operations, subtraction and division. You know division's rank is higher than subtraction. So 15 divided by 3 is 5. Start right from left side to right side. So we have 30 minus 8 minus 5 times 2 square. Now again in bracket, we have 8 minus 5 is 3. So 30 minus 3 times 2 square. And when you have only one number, you don't need to put bracket to that. Okay, next come the exponents. 2 square, which means 2 times 2 is 4. Since exponent is rank higher than subtraction and multiplication, so 30 minus 3 times 4. Now multiply 3 by 4 before subtracting 3 from 30. Because we know that multiplication is rank higher than subtraction. So we have 30 minus 12, which equals 18. The last one. First bracket. Here we have two of them. You can do the stuff inside the brackets both at a time or one by one. I'm going to do both because I have a confidence to do it now. Okay, in the first bracket, do the exponent first before subtract and add. Since exponent is rank higher than addition and subtraction, 3 square is 3 times 3, which equals 9. And in my second bracket, we have two operations, division and multiplication. Both of them rank equally. So just go left to right. 42 divided by 2 is 21. So we have 2, 20 minus 9 plus 1 minus 21 times 3. Now again in the first bracket, we have two operations, subtraction and addition. Both of them rank equally. So just go left to right. First I write 2 here, then 20 minus 9 is 11. And that 11 plus 1 is 12. Minus, in the second bracket, 21 times 3 is 63. Remember, when you have only one number, you don't need to put bracket to that. And we know that bracket or parenthesis is another form of multiplication. So we have 2 times 12 is 24. And that 24 minus 63 is negative 39. Hi, let's learn about the absolute value. Absolute value is a measure of numbers distance from 0 on the number line. Even though 3 and negative 3 are different values, they both 3 units away from 0. The absolute value of 3 is 3 and the absolute value of negative 3 is also 3. So in practice, absolute value means to remove any negative sign in front of a number and to think of all numbers as positive or 0. To show that we want the absolute value of something, we put these marks either side. They are called bars. And it doesn't matter which way around we do a subtraction. The absolute value will always be the same. Example, the absolute value of 6 minus 2 is the same as the absolute value of 2 minus 6, which is 4. Here are some more examples of how to handle absolute values. What is the absolute value of negative 3 times 6? Always first calculate what inside the absolute value. So, negative 3 times 6 is negative 18. And the absolute value of negative 18 is 18. That's it. Here is another one. Negative absolute value of 7 minus 2. Again, first calculate what inside the absolute value. So, 7 minus 2 is 5. Then the absolute value of 5 is just 5. And then the first minus gets us negative 5. And the last one, negative absolute value of negative 13. Well, here we don't need to calculate inside the absolute value because it's just negative 13 inside. So, do the absolute value. Absolute value of negative 13 is 13. And then the first minus gets us negative 13. Here is Adam. He needs to walk to his office 40 meters from the station. After walking 25 meters, he realizes he dropped his mobile. He goes back 5 meters, finds it, then continues to his office. One way to represent Adam's journey is like this. By walking 25 meters forward, 5 meters back, and 20 meters forward. Adam ends up 40 meters from the station, yet he walked more than that. Well, absolute value shows us how much he actually walked. 25 meters forward plus 5 meters back plus 20 meters forward for a total of 45 meters. Absolute value can help us calculate distance and solve math problems.
Summary. To put your new knowledge into practice, try the your turn questions below. Hi, let's learn about the associative laws. It doesn't matter how we group the numbers, that is, which we calculate first, when we add or when we multiply. Adding this is the same as this.
It's a rule that we always do what's in the parentheses or brackets first. So,
It also works for other numbers. So, we get this law. Uses. Sometimes it is easier to add or multiply in a different order. Example. What is 18 plus 23 plus 7? Let's group the 23 and 7 as they make 30. But don't go too far. The associative law doesn't work for subtraction. Multiplying this is the same as this. It also works for other numbers. So, we get this law. Example. What is 2 times 23 times 5? Let's group the 2 and 5 as they multiply to 10. The 2 and 5 were not even next to each other. That is okay as they are all multiplies. Summary. To put your new knowledge into practice, try the your turn questions below. Hi. Let's learn about the distributive law. This is what it lets us do.
3 bars of 2 plus 4
is the same as 3 bars of 2 plus 3 bars of 4. So the 3 times can be distributed across the 2 plus 4 into 3 times 2 and 3 times 4. It works for other numbers too. And we get the distributive law. A times B plus C equals A times B plus A times C. Uses. We can break up a difficult multiplication. We can split the 304 into 304. Now distribute the 5 over 304. and the calculation is easy. We can use the distributive law the other way. Here we undistribute the 18 and the calculation is easier. We can use it in subtraction too. Summary. To put your new knowledge into practice, try the your turn questions below. Hi, let's learn about the equivalent rational numbers. But first, let's get some chocolate. Here is half a chocolate. This is 2/4 of a chocolate, and it is still a half a chocolate. Now it is 4/8 and 2/4 and a half. These are all equivalent rational numbers. Equivalent rational numbers have the same value even though they may look different. How do you know rational numbers are equivalent? Because when you multiply or divide both the top or the numerator and the bottom or the denominator by the same number, the rational keeps its value. The rule to remember is change the bottom using multiply or divide, and the same to the top must be applied. So here is why those rational numbers are really the same. When you multiply the top and bottom of 1/2 by 2, you get 2/4. Because 1 times 2 is 2 and 2 times 2 is 4. And when you multiply the top and bottom of 2/4 by 2, you get 4/8. Because 2 times 2 is 4 and 2 times 4 is 8. Dividing. Here are some more equivalent rational numbers, this time by dividing. When we divide the 24 by 3, we get a 8. When we divide the 42 by the same number, 3, we get 14. So 24 over 42 is equivalent to 8 over 14. When we divide the 8 and the 14 by 2, we get a 4 and a 7. So 8 over 14 is equivalent to 4 over 7. Choose the number you divide by carefully, so that the results both top and bottom stay integers. If we keep dividing until we cannot go any further, then we have simplified the rational number, made it as simple as possible. You can make equivalent rational numbers by multiplying or dividing both top and bottom by the same amount. You only multiply or divide, never add or subtract to get an equivalent rational numbers. Only divide when the top and bottom will still be integers. Summary. To put your new knowledge into practice, try the your turn questions below. They have a data, 1 out of every 2 people in the UK is using a car. 1 in 50 of the total population of the UK is using a bike. But the total population of UK is 60 million. How did they figure out that 1 out of every 2 people is using a car and 1 in 50 is using a bike? Did they count one by one? Let's learn in this video that how they do figure it out. Rational numbers are used to find, like they said, 1 out of every 2 people is using a car and 1 in 50 people is using a bike. Moreover, all rational numbers are in the standard form. Now let's learn about the standard form of rational numbers with an example. Just take any rational number. If we cancel the top numerator and the bottom denominator by common numbers repeatedly, at a certain point we cannot cancel. If we cancel in spite of that,
we will get from rational form to decimal form or an integer form. Here is the thing, if we cannot cancel the top numerator and the bottom denominator furthermore, that is the standard form of that rational number. We could understand clearly this with a real life situation. Let's say that there are 400 students in my school and I bring 40 cakes to my school for my birthday. Obviously, I cannot give every cake for every person. So, when thinking about how to divide this, standard form of rational numbers help me. It helped me like, I write the number of cakes I had and the number of students in rational form. That is 40 divided by 400. And as we have seen it earlier, if we cancel the top numerator and the bottom denominator by common numbers repeatedly, at a certain point we get 1 over 10. If we cancel it further, we get 0.1, decimal form. So the last 1 over 10 is the standard form of that rational number. It indicates that if we give 1 cake to 10 people, then 40 cakes will come right for 400 people. This is how I distributed my 40 cakes to all 400 students. Did you notice here that first we took a rational number and cancelled it repeatedly, but at certain point we couldn't cancel further? Did you think that why we couldn't cancel further? Let's see why with the same example. In 40 divided by 400, let's list out the tables of top 40 and the bottom 400 come in. 40 comes in 1, 2, 4, 5, 8, 10, 20 and 40 tables. In the same way, 400 comes in 1, 2, 4, 5, 8 like this. In the end it comes in 400 table. Now let's collect the common tables between 40 and 400. If we compare the top 40 list and the bottom 400 list, there are many numbers in common like 1, 2, 4, 5, 8, 10, 20 and 40. These are called the common factors. We can cancel 40 divided by 400 by any common factors. For instance, let's cancel this with 10. There are 4 tens in 40 and 40 tens in 400. So we get 4 divided by 40. Let's see what are the common factors in this. This 4 comes in 1, 2 and 4 tables and 40 comes in 1, 2, 4, 5, 8, 10, 20 and 40. Here 1, 2 and 4 are common factors. If we want to cancel it further, we have to with 4 table. There are 1 4 in the numerator 4 and 10 4s in the denominator 40. We get 1 over 10. If we see the common factors of 1 and 10, 1 comes in 1 table and 10 comes in 1, 2, 5 and 10 tables. Now as there is only 1 is the common factor, no use of cancelling 1 with the numerator and the denominator because you get the same result, right? So when it comes to cancel such a big rational number, the last form is the standard form of rational number. Now I hope you understand the standard form of rational numbers. This is how they use the standard form of rational number to find that 1 out of 2 people in the UK is using a car and 1 in 50 of the total population of UK is using a bike. The same thing can be said like this. In UK, out of 60 million people, 30 million people using a car. At the same time, out of 60 million people, 1.2 million people ride bikes. That is so confusing to say, right? So, simply put it, 1 out of 2 people using a car and 1 in 50 using a bike. You could be understand very clearly by using the standard form of rational number.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the multiply and divide rational numbers. When multiplying two rational numbers together, firstly check that the rational numbers are in standard form. If you need a refresher, see the videos namely Equivalent Rational Numbers and Standard Form of Rational Numbers on simplifying rational numbers. Well, now let's multiply these two rational numbers. 3 over 7 times 8 over 12. 3 over 7 is already in the standard form. But 8 over 12 is not in the standard form. So we can simplify it by cancelling its top numerator and the bottom denominator by the common factor 4. By doing so, we get 2 over 3. Whenever multiplication sign is between two rational numbers, it means you have a license. You can go and cancel from one rational number's numerator to the another rational number's denominator. And don't cancel the numerator by numerator and the denominator by denominator. To avoid making mistakes while doing this step, imagine we are playing a football match where none of us wants to play against our own teammates and score own goals, right? In the same way, don't cancel the numerator by numerator and the denominator by denominator. Here, you can cancel the denominator of the second rational number 3 by the numerator of the first rational number 3 by the common factor 3. So once you have cancelled down both rational numbers, you can then multiply finally. To do this, all you have to do is multiply the numerators together and then multiply the denominators together. In the end, it is better to check twice if we can simplify the answer further. Here we have done it perfectly. Let's have a look at another example of multiplying two rational numbers together. Now let's divide these two rational numbers 5 over 3 divided by negative 2 over 18. When dividing one rational number by another, you should check to see if any of the rational numbers can be simplified. 5 over 3 is already in the standard form, but negative 2 over 18 is not in the standard form. So, we can simplify it by cancelling its top numerator and the bottom denominator by the common factor 2. We get negative 1 over 9. Next, flip the rational number after the division sign upside down. While doing this, we don't need to bring the negative sign from top to bottom. You always keep the negative sign in the top. This is called the reciprocal of the original rational number. Then change the division sign to a multiplication. Then all you have to do is perform the multiplication as we did in the previous examples. Here, you can cancel the denominator of the first rational number 3 by the numerator of the second rational number 9 by the common factor 3. Now finally multiply the numerators together and then multiply the denominators together. You always multiply the sign first. A number without a sign before it is considered as a positive. So 5 over 1 is actually plus 5 over 1. So a positive times a negative equals a negative. Then 5 times 3 equals 15. And 1 times 1 equals 1. Which is just negative 15, since any number divided by 1 is itself. Here is another example of dividing two rational numbers. Now let's talk about these right here. Complex fractions. Well, complex fractions have fractional expressions with separate fraction in the numerator, denominator, or both. Or to put it simply, complex fractions have rational numbers within rational numbers. We just learned how to divide rational numbers that we could easily remember with the phrase keep it, change it, flip it. I mean, leave the first rational number alone. Next, change the division sign to multiplication and then flip the second rational number. Multiplication of rational number is the easiest, right? Because all you need to do is multiply straight across. So now if you have your rational number written in a less friendly way, all you need to do is take the big or main division line and write it as a regular division sign. Then you just put the numerator on the left and the denominator on the right. You're just doing 3/5 divided by 4/7. Now you can solve it just like before. Okay, if you have 2 over 9/8, you just write it as well the same thing. Just listen to how I said it, 2 divided by 9/8. And remember, you can always write an integer as the number over 1. Here 2 as 2 over 1. Then you do the same thing. If you have 5/3 divided by -6, don't even think about trying to cancel anything out like the 3 and the 6. Just write out 5/3 divided by -6, which we know is just -6 over 1. Now keep it, change it, flip it. And remember that while flipping the number, don't flip the negative sign as well. Always keep the negative sign at the top. And then multiply straight across. As you see, nothing even cancel.
Summary. To put your new knowledge into practice, try the your turn questions below. Hi. Let's learn about the addition and subtraction of the rational numbers. Basically, there can be two different situations while doing addition and subtraction of rational numbers. Type 1. Adding or subtracting rational numbers that have same denominators. Type 2. Adding or subtracting numbers that have different denominators. Now start with type 1. There are 3 simple steps to add or subtract rational numbers with the same denominator. Step 1. Put the big divide and leaves the common denominator. Step 2. Add or subtract the numerators. And step 3. Check if we can simplify or to make the resulting rational number in standard form if needed. It is very simple. Let's see some examples. To add 2 over 7 and 1 over 7, you just put the big divide and leaves the common denominator first, because the denominators are same. Then add the numerators 2 and 1. We get 3 over 7. Here the resulting number 3 over 7 is already in the simplest form. In other words, it is in the standard form of rational number. So, it is our final answer. Next one, 1 over 4 plus 1 over 4. Denominators are same, so just leave the denominator first. Then add the numerators, we get 2 over 4. Here we can simplify by cancelling the numerator and the denominator by the common factor 2. We get 1 over 2. Yes, it is right. Quarter plus quarter equals half. Now let's move on to the third one. 3 over 8 minus 1 over 8. Same steps for the subtraction. Put the big divide and leaves the common denominator first.
and subtract the numerator. We get 2 over 8. We can simplify this by cancelling the numerator and the denominator by common factor 2. We get 1 over 4. The last one of this page, 6 over 9 minus 7 over 9 plus 4 over 9. Same steps for more than two numbers too. Since the denominators are same, put the big divide and leaves the common denominator first. Next, write the numerator as it is with the operations minus and plus in between. Now let's consider the first two numbers. 6 minus 7 equals minus 1. Then plus 4 over 9. Here we know negative 1 plus 4 equals 3. We get 3 over 9. If we cancel this by 3, we get 1 over 3. We cannot simplify this further since this is in the standard form of rational number. So, it is our final answer.
Summary. To put your new knowledge into practice, try the your turn questions below.
Now let's add or subtract rational numbers that have different denominators. There are two ways to add and subtract rational numbers that have different denominators. One is cross multiplication method, another one is LCM method. Cross multiplication method is easy when we are adding or subtracting two smaller digit rational numbers. And when we are adding or subtracting more than two rational numbers or bigger digit rational numbers, we use LCM method. Examples. Here we could use cross multiplication method to add 1 over 3 and 1 over 6. In cross multiplication method, there are 5 steps to add or subtract rational numbers. Step 1. Put the big divide and multiply the bottom of the second number by the top of the first number. Here 6 times 1, we get 6 and write it here. Step 2. Write the sign between the number whether it is plus or minus. Here write the plus sign. Step 3. Multiply the bottom of the first number by the top of the second number. Here 3 times 1 equals 3 and write it here. Step 4. Multiply the bottoms or the denominators together. Here 3 times 6 equals 18 and if we add the numerators we get 9 over 18. Step 5. Simplify if needed. We could cancel the top and the bottom by the common factor 9. By doing so we get 1 over 2. Cross multiplication method comes with the name because it has a cross like this. Okay, next one. Before we add these two numbers, first remove the brackets by multiplying the signs before and after the bracket. Consequently, we get negative 5 over 9. Then we know that a positive times a negative equals a negative. So negative 4 over 3. Now let's apply the cross multiplication method. Step 1. Put the big divide and multiply the second bottom by the first top. That is 3 times negative 5, which equals negative 15. Step 2. Write the sign between the number whether it is plus or minus. Here minus. Step 3. Multiply the bottom of the first by the top of the second. That is 9 times 4, which equals 36. Step 4. Multiply the bottoms or the denominators together. That is 9 times 3, which equals 27. Now, negative 15 minus 36 equals negative 51. So we have negative 51 over 27. If we cancel the numerator and the denominator by the common factor 3, we get negative 17 over 9. Here, we cannot cancel it further since it's in standard form. So, This is our final answer.
Summary. To put your new knowledge into practice, try the your turn questions below.
We could solve the previous example in LCM method. First, remove the brackets by multiplying the signs before and after the bracket. That's usual. We get negative 5 over 9 minus 4 over 3. Now let's use the LCM method. Before we get into this, let's know about LCM. Well, LCM stands for least common multiple. Firstly, what is multiple? We get a multiple of a number when we multiply it by another number, such as multiplying by 1, 2, 3, 4, etc. but not 0, just like the multiplication table. Here are some examples. The multiples of 2 are 2, 4, 6, 8, 10 and so on. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24 and so on. Now, what is a common multiple? Say we have listed the first few multiples of 2 and 3. The common multiples are those that are found in both lists. Notice that 6, 12 and 18 appear in both lists. So, the common multiples of 2 and 3 are 6, 12, 18 and 24, 30, etc. Now, what is the least common multiple? It is simply the smallest of the common multiples. In our previous example, the smallest of the common multiples is 6. So the least common multiple of 2 and 3 is 6. Here, in this example, there are 3 steps to follow to evaluate negative 5 over 9 minus 4 over 3 using LCM. Step 1. Find the least common multiple of the denominators, which is called the least common denominator. There is the fastest way to get the least common multiple, and the method that I love to use is called the division ladder. For that, start off by writing the denominators on one line like this. Then make an L. Here is what you are going to do. You are going to set up something that looks like an upside down division bar. And we are going to think about prime numbers, any prime numbers that can go into both 9 and 3. Prime numbers? By the way, a prime number is a number greater than 1 which is divisible by 1 and itself. For example, take 5. 5 is divisible by 1 and it is divisible by 5. There is no other number which can divide 5. Hence it's a prime number. Now let's consider 9. 9 is divisible by 1, 3 and 9. Apart from 1 and itself, it is also divisible by 3. Hence, it's not a prime number. Now back to our example. Here we are going to think about prime numbers, any prime numbers that can go into both 9 and 3. The only prime number we can divide them by 3. So we have 3 into 3 is 9 and we have 3 into 1 is 3. Right now, we have a prime number 3 and 1. As soon as you get the prime number or 1 in the division ladder, just close it. That's our endpoint. This is the process to get LCM. So that I am going to make a big L with the outside of my division ladder. And what I am going to do with all those numbers that are contained in the L, just multiply them all together. So LCM is going to be 3 times 3 times 1, which equals 9. Step 2. Change each rational number using the equivalent rational numbers to make their denominators the same as the least common multiple. In order to make the denominators the same, note, what we do to the bottom of the rational number, we must also do to the top. So let's try using it. We want both denominators to have 9. 5 over 9 already has a denominator of 9, but here the denominator is 3. So when we multiply top and bottom of 4 over 3 by 3, we get 12 over 9. Step 3. Add or subtract the rational numbers as you wish. Now we can do the subtraction by subtracting the top numbers. Put the big divide and leaves the denominator 9. Then calculate the numerators -5 minus 12. We get -17 over 9. This rational number already in the standard form, so this is our final answer. Now let's add these numbers in LCM method. So write the denominators 12 and 10 and make an L. Here we are going to think about prime numbers, any prime numbers that can go into 12 and 10. And for me, the only number that come into my mind is 2. So we have 2 into 6 is 12 and then 2 into 5 is 10. Now we have 5 is a prime number but 6 is not. So again I am going to make a division ladder. 6 can be divided by prime numbers 2 and 3. You can divide 6 by either of them first, any one of them is fine. Here I am going to choose 3. So we have 3 into 2 is 6. And here is the thing, 3 cannot go into 5. In this case, just copy the number 5 as such. This is the process to get LCM. Right now we have 2 and 5 which are prime numbers, right? Remember that I told, as soon as you get the prime numbers or 1 in the division ladder, just close it. That's our endpoint in our division ladder. So that I am going to make a big L with the outside of my division ladder, and what I am going to do with all those numbers that are contained in the L, just multiply them all together. So LCM is going to be 2 times 3 times 2 times 5, which equals 60. Because 2 times 3 is 6 and that 6 times 2 is 12, then that 12 times 5 is 60. Now we found the LCM, so here let's try to make the denominators the same. When you multiply 12 by 5, you get 60. And then when you multiply 10 by 6, you get 60. Just make sure that what we do to the bottom of the rational number, we must also do to the top. So, -7 divided by 12 becomes -35 divided by 60. And -3 divided by 10 becomes -18 divided by 60. As you can see now, we change each rational number's denominator the same as the least common multiple. So we can combine the top numbers. First put the big divide and leaves the common denominator 60. Then write the numerators -35 minus 18, which equals -35 minus 18 is -53 divided by 60. This is in the standard form. In other words, we can't simplify it further. So this is our final answer. Now let's try another one in LCM method. LCM method makes our calculation easy when we are dealing with bigger numbers and more than 2 rational numbers. So first write the denominators 16, 24 and 30 and make an L. Here we are going to think about prime numbers, any prime numbers that can go into 16, 24 and 30. And for me, the only prime number that come into my mind is 2. So we have 2 into 8 is 16. Then 2 into 12 is 24. And we have 2 into 15 is 30. Right now we have 8, 12 and 15. These are all not prime numbers. So again I am going to make a division ladder and think about prime numbers, any prime numbers that can go into 8, 12 and 15. no prime number can divide all these numbers simultaneously, right? So that I'm going to think about prime numbers that can go into at least two of them. For me, the prime numbers that come into my mind are 2 and 3. I'm gonna choose 3 here, any one of them is fine. So, here we cannot divide 8 by 3, so just copy the number 8 as such. Then 3 into 4 is 12 and 3 into 5 is 15. Right now, I'm gonna try to divide 8 and 4 by the prime number 2, since 8 and 4 are not prime numbers. We have to keep doing it till we get all prime numbers at the bottom of our division ladder. So, 2 into 4 is 8, then 2 into 2 is 4. And 2 cannot go into 5, so just copy the 5 as such. Still, we don't make them all prime numbers. I mean, 4 is not a prime number, right? So, again I'm going to make a division ladder and think about prime numbers, any prime numbers that can go into 4. For me, the only prime number that come into my mind is 2. So we have 2 into 2 is 4. And 2 cannot go into 5, so just copy the number 5 as such. At the moment, we have two prime numbers 2 and 5 and 1 at the bottom of our division ladder, right? Remember that I told, as soon as you get the prime numbers or 1 in the division ladder, just close it. So that I am going to make a big L with the outside of my division ladder, and what I am going to do with all those numbers that are contained in the L, just multiply them all together. So LCM is going to be 2 times 3 times 2 times 2 times 2 times 1 and times 5, which equals 240. So we found the LCM. Now let's try to make the denominators the same. When you multiply 16 by 15, you get 240. Then when you multiply 24 by 10, you get 240. And when you multiply 30 by 8, you also get 240. Just make sure that what we do to the bottom of the rational number, we must also do to the top. So, 3 over 16 becomes 45 over 240 plus 7 over 24 becomes 70 over 240 and minus 11 over 30 becomes minus 88 over 240. As you can see now, we change each rational number's denominators the same as the least common multiple. Now we can combine the top numbers. First put the big divide and leaves the common denominator 240. Then write the numerators 45 plus 70 minus 88. Now calculate the first two numbers 45 plus 70, which is 115. And that 115 minus 88 equals 27. Hence, we get 27 over 240. And if we cancel the numerator 27 and the denominator 240 by the common factor 3, we get 9 over 80. This is in the standard form. In other words, we can't simplify it further. So this is our final answer. Summary. To put your new knowledge into practice, try the your turn questions below. Hi, let's learn about the exponents. The basic idea of multiplication is repeated addition. Example, we can write 2 times 3 as 2 3's being added together. And when we add those 3's together, we get 6. Here is another example. We can write 4 times 6 as 4 6's, which equals 24. Division is splitting something into equal parts.
Or we can say division is the repeated subtraction of the same number from a larger number down to 0. Example. We need to subtract 2 from 8 repeatedly for 4 times get down to 0. In that row, exponent is the shortened way of writing repeated multiplication. For example, we can write 4 times 4 like this. This 2 on the 4 says to use 4 twice in a multiplication. And 2 is called as exponent or power, 4 is called as base. Both in words, 4 to the power 2 or 4 to the second power or simply 4 square. Here is another one. 3 times 3 times 3 times 3. This 4 on the 3 says that 4 3's being multiplied together. In words, 3 to the power 4. It works for other numbers and expressions too. So, in general, we can write NA's multiplied together as a to the power n. Pay attention when grouping. To avoid confusion, use brackets in cases like these. With bracket, minus 4 the whole square means minus 4 times minus 4, which equals plus 16. Without bracket, minus 4 square means minus of 4 times 4, which equals minus 16. It is important to recognize the difference between expressions such as negative 4 whole square and negative 4 square. In negative 4 the whole square, the brackets indicate that the power applies to the negative sign as well as to the 4. But in negative 4 square equals negative 4 square, the exponent applies only to the 4. So, negative 4 the whole square equals 16 and negative 4 square equals negative 16. On the other hand, with bracket, xy the whole square means xy times xy. Without bracket, xy square equals xy square, which means x times y. Summary. To put your new knowledge into practice, try the your turn questions below. Why any non-zero number power 0 equals 1? Imagine a scenario where you are having an orange. If you double the number of orange you have, you get 2 oranges. Then double the number of oranges you have right now, you will get 4 oranges. Then you double that, you get 8. Further double that, you get 16, and so forth. Let's try to write this scenario in mathematical. Okay, here you have 16 oranges. You got these 16 oranges by doubling an orange 4 times successively. You can write this in exponential form, 2 power 4. I repeat, you got this by doubling an orange 4 times successively. Then 8. You can write this in exponential form, 2 power 3. Because you double an orange 3 times successively, right? Next 4. You can write this as 2 power 2 since we double an orange twice successively. Then 2. You can write 2 power 1 since you double an orange once. Here is the thing. What happens if you double your orange 0 times? Well, that means you haven't started doubling it yet. So you still have one orange. If you want your notation to be consistent, then you should say 2 power 0 equals 1. It works for other numbers too. Summary. In our previous video, we learned that any non-zero number power 0 equals 1. In this video, we are going to see why there is an exception that 0 power 0 is not equal to 1. Before looking at the reason for the exception, let's look at the another way to see that any non-zero number power 0 equals 1. This is just to start out by taking whatever number it is. Let's say we are doing x and write x over x. Well, of course we know x over x is just 1. But another way we can write this x power 1 over x power 1. And if we are dividing two variables, we can go ahead and just subtract their powers, the one on top minus the one on bottom. And of course 1 minus 1 is 0, so there you go, we just show that x power 0 in another way equals 1. So there we did it for x. Now let's go ahead and do it again for 5 just to show that it works exactly the same way. So 5 over 5, that obviously equals 1. On the other hand, I can write that as 5 power 1 over 5 power 1. And then I can take the top power minus the bottom power, which gives us 5 power 0. And at this point, it should be clear that there is nothing special about x or 5. We could put whatever we want, then that would work. Except the one exception to this rule is 0. So 0 power 0 does not equal 1. In fact, 0 power 0 is undefined, which is just a way of saying that we can't say it equals any number. It equals no number. So let's see why that's the case. So we start with the same, we do 0 over 0. The problem is, you remember from our earlier video that you cannot divide it by 0. So 0 over 0 not only does not equal 1, it doesn't equal any number, it's undefined. So already we are stuck and we can't do the same process. So this is why 0 power 0 does not equal to 1. Hi, let's learn about the square numbers. A square number is a number that can be made into a square by using that same number of smaller squares. For example, we can make a square out of 9 smaller squares. But we cannot make a square out of 5 smaller squares, no matter how many different ways we try. What about 6? Therefore, 9 is a square number, 5 and 6 are not square numbers. Have a look at these squares and see if you can work out a rule on how to make a square number. Well, to make a square number, all we have to do is multiply a number by itself. This will always result in a square number. We can represent the process of squaring a number by using the power of 2. When you see a power of 2, it can be read as squared. For example, 5 times 5 can be read as 5 squared. Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the square root. Here we have a square which represents a square number. Area of this square is 16 square centimeters. Therefore, 16 is a square number. A square root is the number that, when multiplied by itself, makes the square number. So what is the number we multiply by itself to be 16? 4. This is the root of the square, the number which is made 16. Can you think of any other number which when multiplied by itself makes 16? -4. Because -4 times -4 equals 16. For every square number there are two roots, a positive root and a negative root. You can use this symbol to represent both numbers, the positive or the negative. And this symbol represents the square root. The symbol is called a radical. And any number that inside the radical is called a radicand. When performing calculations, it is usually the positive root is required. Let's have a look at another square number. Can you identify the square root of 25?
Summary. To put your new knowledge into practice, try the your turn questions below.
The easiest way to find the square root of any number is to use a calculator. But if you are asked to find the square root of a number without using a calculator, there are two ways in which we can do it. The first method is phenomenally simple. It is called the prime factorization method. We will look at the second method in the coming videos. If you have watched the previous video, you should be familiar with what square roots are. So we can look at square roots of slightly larger numbers in this video. So we want to find the square root of 784. Our aim is very simple. We have to reduce this number to its prime factors. That's all. How do we do it before we go ahead? Let us revise what prime numbers are. A prime number is a number which is divisible by 1 and itself. For example, take 7. 7 is divisible by 1 and it is divisible by 7. There is no other number which can divide 7. Hence, it's a prime number. Now let's consider 8. 8 is divisible by 1, 2, 4 and 8. Apart from 1 and itself, it is also divisible by 2 and 4. Hence, it's not a prime number. So let us start reducing the number 784 into prime factors. So we write 784 here and draw two lines like this. Prime factors are the factors of this number which are prime. Since 784 is an even number, undoubtedly it can be divisible by 2. Now, for ease to divide 784 by 2, let's consider 784 as digit by digit. First, 7. 2 3s are 6, so remaining 1. It joins with the next digit 8, so it becomes 18. 2 9s are 18, then 2 2s are 4. Consequently, we get 392. 2 is prime, but 392 is not. So let's reduce 392 further. Since 392 is even, we can divisible it by 2. Same procedure we are gonna follow. In 392, consider 3. 2 1s are 2, so remaining 1. It joins with the next digit 9, so it becomes 19. 2 9s are 18. Remaining 1 again. It joins with the next digit 2. Therefore it becomes 12. 2 6s are 12. We get 196, which is also not a prime number. Since it's even, we can divisible it by 2. Here, we cannot divide 1 by 2, right? In this kind of situation, consider the next digit 2. That's 9. With a number we cannot divide. That's 1. Together, 19. But before we dividing this, we should write 0 underneath. Some people might think it is not necessary to put 0 before an integer. Yeah, in this situation it is okay. In the next videos, you will see its importance. So let's consider the first two digits 19. 2 9s are 18, remaining 1. It joins with the next digit 6, so it becomes 16. 2 8s are 16. We get 98, which is also not prime. Hence we continue with this process. 98 is also divisible by 2. Hence, we write a 2 here and 2 multiplied by 49 gives us 98. 49 is not prime, and we can say that 7 times 7 equals 49. That's where when we stop when we get a prime factor here. So if we look carefully, we have got all the prime factors. 2 times 2 times 2 times 2 times 7 times 7. Now we are getting to the most important point. How will this help us find the square root of 784? You will not believe how simple it is. We write this as square root of 2 times 2 times 2 times 2 times 7 times 7. We have to make groups of two same numbers. This can be our first group 2 and 2. We can make another group again 2 and 2, then 7 and 7. We basically form pairs of same numbers. So we have 3 pairs of same numbers. Once we form pairs to find the square root, all we have to do is pick one number from each pair and multiply them. So from the first and the second pairs, we pick 2, and from the third pair, we pick 7. And we multiply 2 2s and 7, which gives us 28. At first this seems long, but with practice it gets very simple. All we did is broke down the number to its prime factors, made pairs, choose one number from each pair and multiplied them. Now let's try finding the square root of 9025 using the prime factorization method. Hence, our aim would be to reduce 9025 into its prime factors. So we write 9025 here and draw two lines like this. As we know, 9025 ends with 5. Without a doubt, the number can be divisible by the prime number 5. Now for ease to divide 9025 by 5, let's consider 9025 as digit by digit. First 9. 5 ones are 5, so remaining 4. It joins with the next digit 0. So it becomes 40. Now 5 8s are 40. Then here is the thing. We cannot divide 2 by 5, right? In this kind of situation, consider the next digit 2. Here 5. With the number we cannot divide, that's 2. Together 25. But before we executing this, we should write 0 underneath. So 5 times 5 is 25. We get 1805. Which is not prime, and it is also ends with 5. So that can be divisible by 5. Let's take this digit by digit. We cannot divide 1 by 5. So consider first two digits together, 18. Before that, you might think we have to put 0 underneath, right? But here, it is not necessary because there is no change in values writing zeros before a number. Yeah, like 007. Back to the thing. 5 3s are 15. So remaining 3. It joins with the next digit 0, so it becomes 30. Now 5 6 are 30 and 5 1s are 5. So we get 361, which is not prime. So let's reduce 361 further. Well, 19 times 19 is 361. And yes, we stop here since 19 is a prime number. Hence, the square root of 9025 can be written as the square root of 5 times 5 times 19 times 19. The next step is to make the pairs of same numbers, and after we find the pairs, we choose one number from each pair. So we have two pairs here, a pair of 5s and a pair of 19s. We choose one from each pair, so from the first pair we choose 5, from the second pair we choose 19. And to find the square root, all we have to do is multiply these numbers, 5 times 19, which equals 95. Hence, the square root of 9025 is 95. This part of the problem where we choose one number from each pair is really simple. What we really need to be good at is finding out the prime factors quickly. Here is another interesting thing you need to know. Finding the prime factors of large numbers can be difficult and tedious. So, yes, there is a better way to find them, which we will see in the coming videos. In basic arithmetic class, we all come across this way, or at least use this when we are dividing one number by another. This is what long division for dividing numbers. Okay, before we getting into the topic of this video, here I just want to recall some names. The number inside is called dividend. The number outside left here is called divisor. The number on top is called quotient. The number at the bottom is called remainder. Well, in the next part of the video, we are going to use this method, long division. Not for dividing numbers, but finding square roots. In our previous videos, we learned that to find the square root of a number using the prime factorization method. And I told in that video, if the radicand or the square root of a number is large, prime factorization method will take us a lot of time to reduce the number to its prime factors. And the chances of going wrong are very high. Hence, prime factorization method is useful only for small numbers. And for large numbers, we can use the long division method. Let's solve some examples to understand how the long division method works. Okay, if we have to reduce this number to its prime factors, we would first have to think of all the divisibility rules. And that would take us a lot of time. So for such large numbers, we use the long division method. The first thing we need to do in the long division method is to draw lines like this. A line on top and a line to the left of the number. When you draw a line on top of the number, remember to leave some space above the number. Once you are done drawing these lines, you are ready for the first step. The first step is group the digits in pairs, starting with the digit in units place. Here the units place is the number 9. So we mark pairs of digits from right hand side. This becomes our first pair from the right, the number 89. We continue to mark pairs till we cover all digits of the number. The next pair will be 68. So the first step was simple. We just mark pairs from the right, which gives us two pairs, 68 and 89. In the second step, think of the square number or perfect square is equal to or just less than the first pair. Well, here our first pair is 68. Since 68 is not a square number, we choose the square number lower than 68. The square number just lower than 68 is 64. Even 49 is a square number lower than 68, but remember, we always choose the one which is closest. We know that 8 square equals 64. We just found out the most crucial number, it is the number 8. 8 is basically the square root of the closest square number. So, we write the number 8 here to the left of the number and as the quotient. This is actually the most important step of the long division process, to find the first number. If we go wrong here, then the rest of it will definitely be wrong. Okay, now, we do like the regular division process. Multiply the divisor 8. and the quotient 8. So 8 times 8 is 64. That I write it under our first pair 68. And we subtract them. 68 minus 64 is 4. The next step is one of the easiest steps. Bring the next pair down. The next pair is 89 and write it down to the right of the number 4. Now the new dividend is 489. So we have completed 3 steps so far. First, we found the pairs from the right. Second, we found the square number and wrote a square root here left and top. And then we did regular division process. Third, we bring down the next pair. Now the fourth step is to find the new divisor. For that, multiply the earlier quotient, that is 8, by 2 and write it here. If you observe it well, you could see that I have left blank spaces next to our new divisor 16. And in this blank space, we will be writing some digit. Okay, the next step is the most interesting step of the long division method. We use trial and error to find the digit in the blank space. Here we look for the product of two numbers which gives us 489. This is how the product should look. What number do you think we can write in the blank space to get 489 or closely less than 489 as our product? Remember, the digits in both the blank spaces have to be the same. Okay, now here is a trick you need to remember. This trick can be used only when there are no more pairs left here. Since 89 was the last pair we brought down, we can use this trick. We know both blank spaces contain the same digit and any digit from 0 to 9 can be it. That doesn't mean we try all digits one by one starting from 0 until we reach 9. Just look at the units digit of the result we want, it's 9. So the product of the two digits in the blank space must have 9 as the units digit. So we narrow down our possibilities to just two choices. 3 times 3 equals 9 or 7 times 7 equals 49. Both have the units digit as 9. It will either be 163 times 3 or 167 times 7. So, the digit in the space will either be 3 or 7. The first product gives us 489 and the second product gives us 1168. So, the digit in the space should be 3. After we find the digit in the space, we put 3 in the blank space in the left side here and right next to the quotient like we did in our second step. Now, we do like the regular division process. Multiply the new divisor 163 by the quotient 3. 163 times 3 is 489. That I write it under 489. Then we subtract the product from the number above it. That's 489 minus 489, we get 0. The moment we get a 0 here and there are no more pairs left, we are done. But where is the square root of 6889? Well, it's the number you got on top. It's 83. Hence, the square root of 6889 is 83. Okay, because it's a bit lengthy, it's better to check whether our answer is correct or not. But how? Well, one way is to multiply the answer with itself and see if we get the original number. Like 83 times 83 is 6889. The other way is interesting. This number here plus its unit digit will always be twice of the answer. 163 plus its unit digit 3 is 166, which is equal to 83 multiplied by 2. So that's it. We have done it perfectly.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the square root of product. To simplify a square root, make the number inside the square root as simple as possible, but still a whole number. Example, square root of 12 is simpler as 2 square root of 3. Let's check them with the calculator. They are both the same value. So here is the rule. When a and b are not negative, square root of ab equals square root of a square root of b. And here is how to use it. Simplify square root of 12. Before we apply the product rule of square root, here looking at the square root of 12, first you should check to see it is a perfect square. 12 is not a perfect square. There is nothing times itself that equals 12. Anytime you are dealing with radicals, you want to make sure that there is completely simplified. The square root of 12 is not completely simplified because 12 is divisible by a perfect square of 4. A radical is only completely simplified when it is not divisible by any perfect square underneath the radical. Here we know that 12 is 4 times 3. So we write square root of 12 equals square root of 4 times 3. Now use the product rule. Square root of 4 times 3 equals square root of 4 times square root of 3. And the square root of 4 is 2. Therefore, square root of 4 times square root of 3 equals 2 square root of 3. So, square root of 12 is simpler as 2 square root of 3. We can use the product rule of radicals other way. First, let's combine the numbers inside the square roots. So, square root of 6 times square root of 15 equals square root of 6 times 15. Then reduce them into its prime factors. That's square root of 2 times 3 times 3 times 5. Then we can see 2 3's inside the radical. Let's pull them out. We get 3 square root of 2 times 5, which equals 3 square root of 10.
Summary. To put your new knowledge into practice, try the your turn questions below.
We have learned the square root of product of numbers in the previous video. Here is a similar rule for fractions, namely quotient rule. This rule states that if we have a fraction with a radical in the numerator and the denominator, we can take the radical in the numerator and the radical in the denominator and put them in a fraction underneath one square root. This question is asking us to simplify the expression the square root of 152 over the square root of 19. In order to simplify this expression or expressions like it, we have to know the quotient rule of radicals or square roots. That's what we just saw earlier. Before we apply the quotient rule of square root, here looking at the square root of 152 over the square root of 19. First, you should check to see if either of them is a perfect square. 152 is not a perfect square. There is nothing times itself that equals 152 and the same goes for 19. There is nothing times itself that equals 19. So we can go ahead and try to break this as one fraction. That's the step 1 of the quotient rule of radicals. So square root of 152 over 19 all under one radical. Step 2. See if we can simplify the fraction underneath the radical. This will simplify to the square root of 8. Anytime you are dealing with radicals, you want to make sure that there is completely simplified. The square root of 8 is not completely simplified because 8 is divisible by a perfect square of 4. A radical is only completely simplified when it is not divisible by any perfect squares underneath the radical. Step 3. Simplify the square root using perfect squares if possible. Therefore, we know that 8 is 4 times 2. So we write square root of 8 equals square root of 4 times 2. Now, use the product rule of radicals. Square root of 4 times 2 can be written as square root of 4 times square root of 2. And the square root of 4 is 2. Therefore, square root of 4 times square root of 2 equals 2 square root of 2. Let's look at another example. Find the quotient of square root of 312 over square root of 13. Step 1. Use the quotient rule to place both the radicand in the numerator and the radicand in the denominator underneath the same radicand. So, square root of 312 over square root of 13 equals square root of 312 over 13. Step 2. Simplify the fraction underneath the radical, if possible. Therefore, 13 times 24 equals 312. We get square root of 24. Step 3. Simplify the square root using perfect squares, if possible. Therefore, we know that 24 is 4 times 6. So we write square root of 24 equals square root of 4 times 6. Now, use the product rule of radicals. Square root of 4 times 6 equals square root of 4 times square root of 6. And the square root of 4 is 2. Therefore, square root of 4 times square root of 6 equals 2 square root of 6.
Summary. To put your new knowledge into practice, try the your turn questions below. Hi, let's learn about the laws of exponents. Let's calculate the value of 2 power 3 or 2 cube times 2 square. 2 cube means 3 2's multiplied together, and 2 squared means 2 2's multiplied together. So in total 5 times. We can write this in exponential form 2 power 5 and write 5 as 3 plus 2. We observe that the base of 2 cube and 2 square is the same, that is 2. And the sum of the powers is 5. So we can write 2 cube times 2 square as 2 power 3 plus 2. Now let's consider the negative integers as the base. Minus 4 the whole cube times the minus 4 whole square. Minus 4 the whole cube means 3 negative 4's multiplied together. Minus 4 the whole square means 2 negative 4's multiplied together. So in total 5 times. We can write this in exponential form minus 4 the whole power 5. And we write this 5 as 3 plus 2. We observe that the base of minus 4 the whole cube and minus 4 the whole square is the same, that is minus 4. And the sum of their powers is 5. So we can write this as this. It also works for the variable bases when the variable bases are not equal to 0. So in general, when we multiply the exponential numbers with the same base, first write the base and add the powers, where the base should not be equal to 0. Let's simplify this using product rule. We can write 25 as 5 square because 5 times 5 is 25. Okay, I don't know the exponential form of 32. Let's find this by prime factorization, which is the method of breaking down the numbers into multiplication of prime numbers. In other words, Divide the given number by prime numbers repeatedly till you get 1. With prime factorization, we have broken 32 into 5 twos. We can write this in exponential form 2 power 5. Similarly, we can break 64 into 6 twos. So 2 power 6. We get 5 square times. Here we can apply the product rule, which says that when the bases are same, write the base and add the powers. So we get 2 power 11. Summary. To put your new knowledge into practice, try the your turn questions below. Let's learn some rules to divide exponential numbers with the same base. Let's calculate the value of 2 power 6 divided by 2 square. 2 power 6 means 6 2's multiplied together, divided by 2 square means 2 2's multiplied together. We can strike out 2 2's in the denominator and 2 2's in the numerator. Left over is 4 2's. We can write this in exponential form 2 power 4. We write 4 as 6 minus 2. We observe that the base of 2 power 6 and 2 power 2 is the same, that is 2. And the difference of powers is 4. So we can write this as this. Now, let's consider the negative integers as the base. Minus 7 whole power 5 divided by minus 7 whole power 3. Minus 7 whole power 5 means 5 minus 7's multiplied together, divided by minus 7 whole power 3 means 3 minus 7's multiplied together. We can strike out the same numerators and the same denominators when there are multiplications between the numbers. So we can strike out 3 minus 7's in the denominator and 3 minus 7's in the numerator. So the leftover is 2 minus 7's. We can write this in exponential form minus 7 whole power 2. We can write this 2 as 5 minus 3. So we can write this as this. We could also imagine in this way. When we bring the denominator to the numerator, the denominator becomes multiplication of the numerator, and the power becomes its opposite sign. That is, if it is positive, it becomes negative, and if it is negative, it becomes positive. Consequently, we get minus 7 whole power 5 times minus 7 whole power minus 3, which equals minus 7 whole power 5 minus 3. So in general, the quotient rule states that how many times do we end up multiplying a? Answer: m times, then reduce that by n times because we are dividing, for a total of m minus n times, where the a should not be equal to 0. Let's simplify using quotient rule. Firstly, minus 10 whole power 8 divided by minus 10 whole power 6. Here we have same bases in the numerator and in the denominator as well. So let's apply the quotient rule, which states that if you bring the denominator to the numerator, the power of the denominator becomes its opposite sign. Here we have plus 6, so it becomes minus 6. By doing so, we get minus 10 whole power 8 minus 6. which equals minus 10 whole power 2. Next, 7 power 4 divided by 7 power 0. Here we can apply the quotient rule because the base of the numerator and the denominator is same. The quotient rule allows us to bring the denominator to the numerator by giving opposite sign to the power of the denominator. So we get 7 power 4 minus 0, which equals 7 power 4. Let's calculate the last one. Here, firstly I am grouping the exponential numbers with the same base. Like, if I write 2 power 8 in the numerator, its straight down denominator is 2 power 4. We don't need to worry about the result because multiplication is commutative. Now let's apply the quotient rule. It says that if we bring the denominator to the numerator, the power becomes its opposite sign. We get 2 power 8 minus 4 times 3 power 4 minus 2 times 5 power 7 minus 2, which equals 2 power 4 times 3 squared times 5 power 5. Summary. To put your new knowledge into practice, try the your turn questions below. Hi. Let's learn about the exponents with a different base and same powers. To understand the multiplication of exponent numbers with different base and same powers, let us consider this example. 2 power 5 times 5 power 5. Well, 2 power 5 means 5 2's multiplied together, and 5 power 5 means 5 5's multiplied together. Now, grouping 2 times 5, we get 5 groups of 2 and 5, and we can write this in exponential form, 2 times 5 the whole power 5. We can understand from that we can write this as this. So in general, when multiplying exponents with different bases and same powers, the bases are multiplied first. It can be written mathematically as a multiplied by b the whole power n, where a and b should not be equal to 0. To understand the division of exponent numbers with different base and same powers, let us consider this example. 9 power 3 divided by 4 power 3. Well, 9 power 3 means 3 9's multiplied together, and 4 power 3 means 3 4's multiplied together. Now grouping the 9 divided by 4, we get 3 9 by 4's, and we can write this in exponential form, 9 by 4 the whole power 3. So we can write this as this. So in general, when dividing exponents with different bases and same powers, the bases are divided first. It can be written mathematically as a divided by b the whole power n, where a and b should not be equal to 0. Now simplify by using laws of exponents. Let's start with this one. 4 cube times 2 cube times 5 cube. You may have noticed that there are a total of 3 numbers with different base and same powers. But we have learned for 2 numbers, right? So what? We could extend the rule. That's the beauty of mathematics. We just saw the rule a while back. When we were multiplying 2 numbers with different bases but same powers, we could simply multiply the bases and place the same power. Same steps we are going to follow here. Simply multiply the bases and place the same power. So we write 4 times 2 times 5 the whole cube. and if we multiply them, we will get 40 cube. Next one, 6 power 13 times 48 power 13 divided by 12 power 13. First, I am going to change from this division form to fraction form. We can write 6 power 13 times 48 power 13 by 12 power 13. Here you can see that division of different base and same powers. So we could apply the rule that when dividing exponents with different bases and same powers, the bases are divided first. Here we can cancel top 48 by bottom 12 for 4 times. By doing so, we get 6 power 13 times 4 power 13. Right now, we have multiplication of different base and same powers. So, the bases are multiplied first, right? Consequently, 6 times 4 the whole power 13, which equals 24 power 13. Summary. To put your new knowledge into practice, try the your turn questions below. Hi, let's learn about the power rule. Let us find the value of 3 square whole power 5. The 3 square the whole power 5 means 5 3 squares multiplied together. Here as you can see, the bases are same. So we can apply the product rule, which says that write the base and add the powers. So we get 3 power 10. We can write 10 as 2 times 5. So we can write this as this. It also works for other numbers. So we can write this as this. So in general, the power rule says that first you multiply m times, then you have to do that n times, for a total of m multiplied by n times, where a should not be equal to 0. Now, let's simplify using the power rule. What is minus 7 whole power 3 and the whole square? The power rule says that we do the exponent at the top first. We can multiply them. So, minus 7 whole power 3 times 2, which equals minus 7 whole power 6. Now let's look at this one. 2 power 6 the whole squared multiplied by 2 power 4 the whole power 7. The power rule says that we do the exponent at the top first. We can multiply them. By doing so, 2 power 6 times 2. Similarly, by applying the power rule to 2 power 4 the whole power 7, we get 2 power 4 times 7, which equals 2 power 12 multiplied by 2 power 28. Since bases are same here, we can apply the product rule, which says that write the base and add the powers. Consequently, 2 power 40. Summary. To put your new knowledge into practice, try the your turn questions below. In this video, we are going to use the laws of exponent to simplify each expression. The first one, negative 3a b power 4 times 4a b power negative 3. Usually, when you multiply two things, first multiply their signs. Here, a negative times a positive is a negative.
Secondly, multiply their numbers. 3 times 4 is 12. Lastly, multiply their letters. Here we have a mix of variables. Remember, when we have a mix of variables, just add up the exponents for each. And also remember that a variable without an exponent really has an exponent of 1. So, a times a is a square, or we can write a power 1 plus 1. Since bases are same, write a base and combine the powers. Now let's look at the b's. Write a base b and combine the powers 4 minus 3. So we have negative 12 a square b. Since b is really b power 1. And that's it. Now let's look at this one. Negative 2 xy square the whole power 3. Okay, here remember the power rule which says that if you see the bracket power something, I repeat, if you see the bracket power something, then distribute that power to whatever inside the bracket, whether it be sign or number and or letter. So let's first distribute this power 3 to negative sign, which means negative times negative times negative. So a negative times a negative is positive, and that positive times a negative is a negative. So I write it here. Generally, a negative power odd number is always a negative, while a negative power even number is always a positive. Okay, back to the problem. If we distribute the power to this base 2, we get 2 cube. Then distribute the power to x, we get x cube. And if we distribute the power 3 to y square, we get y square the whole cube. Okay, so we have negative 2 cube is 2 times 2 times 2, which is 8, then x cube. And y power 2 times 3 is 6. Since when you have power to the power or exponent to the exponent, simply multiply their powers or exponents. Actually, this is what we did in our previous case also. We multiply the power of x, which was 1, by the whole power 3. And we have to notice here that we have all the rights to distribute the power to inside the bracket when there is a multiplication sign between numbers and letters. If there were positive or negative between them, we could not distribute like this. Now let's simplify another one. Negative 5x cube over y the whole power 2. This power 2 is for both numerator and denominator. Okay, like in our previous example, let's first distribute the power 2 to the negative sign, which means a negative times a negative is a positive. And we can also think like this, a negative power even number is always a positive. Well, in mathematics, it is not necessary to write plus sign when we start writing. Okay, next, if we distribute the power 2 to the base 5, it will be 5 square. Now let's distribute the power to the base x cube. We have x cube whole square. And if we distribute the power to the denominator y, we will get y square. So we have 5 square is 25, then x cube whole square is x power 6. Since when you have the power to the power or exponent to the exponent, simply multiply their powers or exponents and divided by y square. That's it, we're done. Now let's simplify this one. 3m times negative 4m power 5 the whole power 0. We know that any non-zero number power 0 is 1. So, this non-zero quantity power 0 is 1. So we have 3m times 1, which is just 3m. In this video, we are going to rewrite each expression with positive exponents. And our goal will be to write each expression in their simplest possible form. Okay, let's start with this one. X power negative 1. This x can be written as x divided by 1. Now this power negative 1 is included for both the top x and the bottom 1. And remember, we learned from the negative exponent video that from the negative exponent, if we give the negative alone to the base will be reciprocal. Therefore, reciprocal of x divided by 1 is 1 divided by x and whole power 1, which is just 1 divided by x. Since any number power 1 is that number. And we can also think like this. If you bring a term from the numerator to the denominator or vice versa, then the sign of the exponent will only change. Like if the exponent is positive, then it becomes negative. If the exponent is negative, then it becomes positive. Moreover, there is a special name for putting a little negative one. That's called multiplicative inverse. So, x power negative 1 can be read as x inverse. And like x inverse is 1 by x, y inverse is 1 by y, 5 inverse is 1 by 5 and so on. But not for 0, because multiplicative inverse of 0 is undefined. Rarely in algebra is there only one way to solve your problem. Don't be concerned if the steps you use to solve your problem are not exactly the same as the steps presented in our videos. The important thing is to use steps that you understand and, of course, steps that are justified by the rules of algebra. Now let's look at this one. 1 divided by 3x power negative 2. Here in the denominator, x has negative exponent. In order to write it with positive exponent, let's bring this x power negative 2 to the numerator. So we have 1 times x square divided by 3. Because we brought the term from the denominator to the numerator, we change the sign of the exponent. See, it was negative, now it's positive. And after bringing it, multiply it with the one already on numerator. Okay, we get 1 times x square is x square divided by 3. That's it, since we can't go further. Okay, now let's rewrite this with positive exponent. For that, from the exponent, if we give this negative alone to the base will be reciprocal. The reciprocal of 3x square divided by y is y divided by 3x square and whole power 2. The power 2 is for both the numerator and the denominator. So if we distribute the power 2 to the numerator y, we get y square divided by, okay, now let's distribute the power to the denominator. If we distribute the power 2 to the base 3, then it will be 3 square. Next, if we distribute the power 2 to the base x square, we get x square the whole square. So we have y square divided by 3 square is 9, then x square the whole square is x power, just multiply the powers. 2 times 2 is 4. Since power rule for exponent says that when you have power to the power or exponent to the exponent, simply multiply the powers or exponents. That's it. We're done. Now let's try this one. 12a cube b power negative 4 divided by 4a power negative 2 b. Okay, in this expression, two terms are having negative exponents. One is in the numerator, that is b power negative 4. Another one is in the denominator, a power negative 2. So, first I am going to rewrite the negative exponent terms into positive exponent. For that, I am going to bring this a power negative 2 to the numerator. At the same time, bringing this b power negative 4 to the denominator. By doing so, we get, in the numerator, 12a cube. And if I bring this a power negative 2 to the numerator, it becomes a square divided by 4b. And if I bring this b power negative 4 to the denominator, it becomes b power 4. Now let's simplify. We can cancel the numerator 12 and the denominator 4 by the common factor 4. We get 3 in the numerator. Then here, we can apply the product rule which says that when the bases are same, just write a base and combine the powers. We get a power 3 plus 2 divided by, here also we can apply the product rule because bases are same and there is a multiplication sign between them. So we have b power 1 plus 4 because we know that just b is really b power 1. Hence 3a power 5 divided by b power 5. Now let's try this one. 21a power negative 8 b power negative 3 c power 6 divided by 35a power negative 2 b power negative 1 c power negative 4. Okay, in this expression, 5 terms are having negative exponents. 2 in the numerator, 3 in the denominator. So, first I am going to rewrite the negative exponent terms into positive exponents. For that, I am going to bring this a power negative 8 and b power negative 3 to the denominator, while bringing this a power negative 2, b power negative 1, c power negative 4 to the numerator. Consequently, we get, in the numerator, I just copy the 21 and c power 6 which I didn't use. Then if we bring this a power negative 2 to the numerator, we get a square. Then if I bring this b power negative 1 to the numerator, we have b power 1 or just b. And if I bring this c power negative 4 to the numerator, we get c power 4 divided by, in the denominator, I am just bringing down the 35 which I didn't use. Then if we bring this a power negative 8 to the denominator, we get a power 8. And finally, if we bring this b power negative 3, we get b power 3. Let's start simplify now. So what do you think we need to do? We can cancel the numerator 21 and the denominator 35 by the common factor 7. By doing so, we get 3 in the numerator and 5 in the denominator. And c power 6, c power 4 is c power 10. Since bases are same, write a base and combine the powers, 6 plus 4. Then we can cancel the numerator a square and the denominator a power 8. We have a power 6 in the denominator. Since we know that a square is nothing but 2a's multiplied together, while a power 8 is 8a's multiplied together. So by cancelling 2a's both in the numerator and the denominator, we have 6 a's in the denominator, which is just a power 6. Likewise, if we cancel the numerator b or b power 1 and the denominator b cube, we get b square in the denominator. And that's it. Since we have rewritten all the negative exponents to positive exponents and we can't simplify further.
Hi, let's learn about the scientific notation. Exponents provide an efficient way of writing and computing with very large or very small numbers. For instance, there are about 1/60,260 quintillion liters of water on Earth. That is 126 followed by 19 zeros. It is convenient to write such numbers in scientific notation. This notation has the form plus or minus c multiplied by 10 power n, where c is between 1 and 10. Moreover, 1 is included but 10 is not. Then n is any integer. As you can see, there is no decimal point in this number, which means the decimal point is in the last. As per the scientific notation, before the decimal point the number has to be 1 to 9. So let's drag the decimal point prior to 21 places or digits, that is, behind the number 1. So the number of liters of water on Earth can be written in the scientific notation as 1.26 multiplied by 10 power 21. The positive exponent 21 indicates that the number is large and the decimal point has been moved 21 places. A negative exponent indicates that the number is small, less than 1. For instance, the size of a bacterium is approximately 0.0000085 mm. As per the scientific notation, before the decimal point the number has to be 1 to 9. So let's drag the decimal point after 7 places or digits, that is, behind the number 8. So the size of a bacterium can be written in the scientific notation as 8.5 multiplied by 10 power minus 7 mm. To figure out the power of 10, think how many places do I move the decimal point. When the number is 10 or greater, the decimal point has to move to the left and the power of 10 is positive. When the number is smaller than 1, the decimal point has to move to the right, so the power of 10 is negative. More examples. Write the following in scientific notation. Let's solve the first one. Scientific notation says that before the decimal point, the number has to be 1 to 9, but here's 0. So let's drag the decimal point after 5 places, that is after 7. We can be written in scientific notation as 7.82 multiplied by 10 power minus 5. Now let's look at this one. There is no decimal point in this number, which means the decimal point is being in the last. The scientific notation says that before the decimal point the number has to be 1 to 9. But here is a large number. So let's drag the decimal point prior to 11 places, that is after 4. By doing so, we can write this in scientific notation as 4.678 multiplied by 10 power 11. The last one. Again, the scientific notation says that before the decimal point the number has to be 1 to 9. But 1642 is here. So let's drag the decimal point prior to 3 places, that is after 1. We could be written this in scientific notation as 1.642398 multiplied by 10 power 3. Let's now multiply a very small and a very big number. For example, in order to multiply 2 times 10 power 7 and 3 times 10 power minus 11, first we grouping like things. Here 2 and 3 first, then 10 power 7 and 10 power minus 11. So 2 times 3 is 6. Here we can apply the product rule, which says that when the bases are same, write the base and add the powers. By doing so, 10 power 7 plus minus 11, which means 6 times 10 power 7 minus 11. So we get 6 times 10 power minus 4. Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the algebraic expressions. One characteristic of algebra is the use of letters to represent numbers. The letters are variables, and combination of letters and numbers are algebraic expressions. Here are a few examples of algebraic expressions. 5x, 2x minus 3, 4 over x squared plus 2, and 7x plus y. An algebraic expression is a collection of letters or variables and numbers or constants combined using the operations of addition, subtraction, multiplication, division, and exponentiation. Parts of an algebraic expression. So people can talk about the expressions. There are names for different parts. The terms of an algebraic expression are those parts that are separated by addition. For example, x square minus 5x plus 8, which can be written as x square plus minus 5x plus 8, because we know that a positive times a negative equals a negative. This algebraic expression has three terms. X square and minus 5x are the variable terms, and 8 is the constant term. A coefficient is a number used to multiply a variable. For instance, minus 5x means minus 5 times x. So, minus 5 is a coefficient. And the coefficient of x square is 1. Variables on their own without a number next to them actually have a coefficient of 1. X square is really 1x square. Sometimes a coefficient is a letter like a or b instead of a number. Example, ax square plus bx plus c. Here, x is a variable, a and b are coefficients, and c is a constant. Now let's identify the terms and the coefficients of algebraic expressions. In the algebraic expression, 5x minus 1 over 7 has two terms. 5x is the variable term and negative 1 over 7 is the constant term. Then the coefficient of x is 5. Next one. This algebraic expression has three terms. 2x square and negative 6x are the variable terms and 9 is the constant term. Then the coefficient of x square is 2 and the coefficient of x is negative 6. The last one, it has three variable terms, all of them. 3 over x, 1 over 2x power 4 and negative y. Then the coefficient of x is 3, the coefficient of x power 4 is 1 over 2 and the coefficient of y is negative 1.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the like and unlike terms. When you see a market, you can see that the vegetables and fruits of same kind are kept as separate heaps. Similarly, we can group the same kind of terms in an algebraic expression. For example, the expression 7x plus 5x plus 12x minus 16 has 4 terms. But the first 3 terms have the same variable x and their powers are 1. We say that 7x, 5x and 12x are like terms. Hence, like terms are terms whose variables and their powers are the same. However, the terms 12x and minus 16 have different variable factors. The term 12x has the variable x and the term minus 16 is a constant. Such terms are called unlike terms. Consider another example. In the expression 14xy minus 7y square minus 12yx plus 5y square minus 10, the terms minus 7y square and 5y square are like terms. Also, 14xy and minus 12yx are like terms. But we cannot group the terms 14xy minus 7y square and minus 10 as they don't have the same variables and the powers, thus called unlike terms. Here, terms with the variables xy and yx are like terms because of the commutative property of multiplication. X times y equals y times x. Here are a few people might ask, if constant terms are like terms, for instance 16 and negative 45, then where are the variables and their powers of 16 and negative 45? Well, we saw in an earlier video that any non-zero number power 0 equals 1. By that, here you can write 16 as 16x power 0, which is just 16 times 1, that's 16. Similarly, negative 45 can be written as negative 45x power 0, that is purely negative 45. We could understand through that all constants could have the same variables and their powers are also same, that is 0. Ultimately, constant terms are like terms.
Summary. To put your new knowledge into practice, try the your turn questions below.
On the screen you can see a variety of mangoes and apples, but it's not very clear to immediately determine how many mangoes and apples there are. So what we are going to do is count each of the fruits and combine the like fruits to make a simplified expression. Altogether there are 9 mangoes and altogether there are 7 apples. So instead of keeping each fruit by itself, we are going to combine them. When we do this, we can write the simplified expression 9 mangoes plus 7 apples. And my goodness, that's a lot easier to look at. This is an example of combining like terms. Taking something that is separated or looks complex and combining the terms together to make a simplified expression. You can add and subtract expression in much the same way you add and subtract numbers. Simply add or subtract the like terms by adding their coefficients. For instance, negative 3xy square and 5xy square are like terms.
and their sum is negative 3 plus 5 of xy square, which equals 2xy square. So, there are two steps to add or subtract expressions. Step 1. Group like terms together. Step 2. Add or subtract like terms. Now let's add these two expressions. Start with 2x square plus 6x plus 5 plus 3x square minus 2x minus 1. In order to add these two expressions, there are two steps. Step 1. Grouping like terms. We know that like terms are terms having the same variables to the same powers. So, 2x square plus 3x square plus 6x minus 2x plus 5 minus 1. Step 2. Add or subtract like terms, which is 2x square plus 3x square equals 5x square plus 6x minus 2x equals plus 4x and plus 5 minus 1 equals plus 4. Now let's combine these expressions. You always distribute before you combine, so I'm gonna go ahead and distribute this too. Whenever you see a number before brackets, it means to distribute. So I'm gonna distribute this 2 to the 4x, my first term inside of my brackets, and so the 3, the second term inside my brackets. So 2 times 4x is 8x. 2 times positive 3 is positive 6. And now I'm just bringing down anything that I didn't use, which is my minus 3x. So I have distributed and now I'm looking to combine like terms. So the only like term I see here are 8x and negative 3x. The most important thing about combining like terms is that you take the sign before the term. So every term has to carry the sign before it. Think of it as its little leash. Okay, the 8 doesn't have that because it's the leading coefficient, but that just means that it's positive, or it's no need to put plus sign when you start something in math. And bring down the plus 6. So, I'm doing 8x minus 3x, which is 5x. When you combine like terms, you only deal with the coefficients and you keep the variable the same. And now I'm gonna bring down my plus 6 because there is nothing to combine that with. And done. So to distribute, you multiply the number outside of the brackets by each term that's inside. And to combine like terms, you look for anything that has the same variable and same power. And these both have an imaginary one. That's why I say same power. You combine their coefficients, keep their variable. Now, let's subtract these two expressions. Start with 7x power 4 minus x square minus 4x plus 2 minus 3x power 4 minus 4x square plus 3x. And most importantly, we should put brackets for this expression after the negative sign, because this negative sign is for each term of the expression. That is for 3x power 4 minus 4x square plus 3x. In order to combine these two expressions, there are two steps. But before that, we should distribute the negative sign to each term inside the brackets. By doing so, we get 7x power 4 minus x square minus 4x plus 2 minus 3x power 4 plus 4x square minus 3x. Now let's grouping the like terms. 7x power 4 minus 3x power 4 minus x square plus 4x square minus 4x minus 3x plus 2.
Step 2. Add or subtract like terms. Here, 7x power 4 minus 3x power 4 equals 4x power 4. Minus x square plus 4x square equals plus 3x square. Minus 4x minus 3x equals minus 7x. And left over is plus 2. Warning: when an expression inside brackets is preceded by a negative sign, remember to distribute the negative sign to each term inside the brackets. Negative of x square minus x plus 3 equals negative x square plus x minus 3.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about multiply the algebraic expressions. When multiplying two expressions, be sure to multiply each term of one expression by each term of the other. Then combine like terms together if possible. Let us look at the simplest cases first. Multiply one term by one term. 2y square times minus 4y. Before you multiply this, remember that when you multiply any two numbers or terms, first multiply their signs, then multiply their numbers, and finally multiply their letters or variables. Well, first multiply their signs. The sign of the expression 2y square is positive. Every term has the sign before it. Okay, the 2y square doesn't have that. We don't put a plus sign in front of a number, since the general understanding is that numbers without a sign are positive. And the sign of this expression is negative. So, a positive times a negative equals a negative. Now, multiply their numbers. 2 times 4 equals 8. Finally, multiply their letters or variables. Remember, a variable without an exponent or power really has an exponent of 1. Here y is really y power 1. So, when multiplying same base as y, simply write a base y and add the powers 2 plus 1. We learned all of that in the rules of exponents early on. So what we are going to have y to the third power, or simply y cube. Now let's multiply these two expressions. Negative 5x square z power 4 times negative 4x cube. Just remember the order. Multiply sign first, then multiply numbers, finally multiply letters. First multiply their sign. A negative times a negative equals a positive. We don't need to put plus sign when we start something in math. So we pass the step 1. Now let's multiply their numbers. 5 times 4 equals 20. Finally, multiply their letters or variables. Here, mix of variables x and z. First, multiply x's, which means write a base x and add the powers of them together, that is x to the power 5. And write the leftover z power 4. Because when variables are the same, we multiplying them together compresses them into a single variable. But you still can't combine different variables. I mean, if the variables are different in both the terms, then multiply them by expressing it as a product of the variables. Remember that multiplication does not require like terms. Addition does, but multiplication does not. Remember that I said in the beginning of this video, when multiplying two expressions, be sure to multiply each term of one expression with each term of the other. Then combine like terms together if possible. Here, in this question, if each of the two terms in the first expression is multiplied by each of the two terms in the second expression, then that is 4 different multiplications. Why? Let's see with an example. Imagine a scenario, two friends Sam and Adam challenge two friends Charles and Abdul to individual chess matches. The question is, how many matches does that make? We can say Sam plays Charles and then Sam plays Abdul. Then Adam plays Charles and then Adam plays Abdul. They could play in any order, so long as each of the first two friends gets to play each of the second two friends. It is the same when we multiply algebraic expressions each having two terms. And we could extend this more than two times. We will see them later. Now let's multiply these two expressions each having two terms. I'm gonna go ahead and distribute my first term here 3cy square to the negative 4cx, my first term inside of my brackets. So it becomes 3cy square times negative 4cx. Then we add this first term multiplied by the second term inside my brackets. We get 3cy square times negative 2xy cube. Then I put in my plus sign again. Then I go to my second term in front inside the first bracket. So I have negative 5. And that negative 5 is multiplied by the negative 4cx, which is negative 5 times negative 4cx. Then I put in my plus sign and I take that negative 5 and multiply it by negative 2xy cube. We get negative 5 times negative 2xy cube. It is always important just to check to make sure you have written things correctly when you are doing. Okay, now let's take this group and it's like the previous problem. One term multiplied by one term. Just remember the order. Multiply sign first, then multiply numbers and finally multiply their variables. So, a positive times a negative equals a negative. Then 3 times 4 equals 12. Now let's multiply their variables. Here, mix of variables c, x and y. First multiply the c's. When multiplying same bases, write a base and add their powers. We get c square. As we know that a variable without a power is actually have a power 1. Then we have a mix of variables, an x and a y. We are going to put x in front because it's alphabetically in front of y. So we have x and then y square. Since when multiplying different variables, multiply them by writing it as a product of variables. Now I am going to put this plus in here and then deal with what's going on inside these brackets. A positive times a negative equals a negative. We shouldn't write the signs plus and minus back to back like this. We have to differentiate these two with the bracket. Then 3 times 2 equals 6. Now multiply their variables. First write c and x, then multiply the y's. When multiplying the same bases, write the base and add the powers. So we get y power 5. Then put plus. Let's multiply these now. Multiply their signs. A negative times a negative equals a positive. Then 5 times 4 equals 20 and cx. Plus a negative times a negative equals a positive. Now multiply their numbers. 5 times 2 equals 10. Then left over variables xy cube. Now I am going to multiply the sign of a second term. A positive times a negative equals a negative. Therefore, negative 12c square xy square minus 6cx y power 5 plus 20cx plus 10x y cube. We cannot combine any terms here because everything is unlike terms. Now let's multiply these two expressions. Start with x square minus 2x plus 2 multiplied by x square plus 2x plus 2. Always remember that I said in the beginning of this video, when multiplying two expressions, be sure to multiply each term of one expression to the each term of the other. And then check if we can combine the like terms together. So I'm gonna go ahead and distribute this x squared to the x squared the first time inside of my second bracket. We get x squared times x squared. Then I put my plus here and so the 2x the second term. We get x squared times 2x. Then plus, and I distribute the x squared to 2 the third term inside that bracket. We get x squared times 2. Like this, I distributed my second and third terms of my first bracket to each term of the second bracket. Now it looks easy. Multiply one term by one term. X squared times x squared equals x power 4. Then I put my plus here. Now x squared times 2x equals 2x cubed. Plus, then x squared times 2 equals 2x squared. You always place the coefficient before the variable. Then plus, negative 2x times x squared equals negative 2x cubed. As we have seen earlier, we shouldn't write more than one sign back to back like this. We have to differentiate these two with the bracket. Now I am going to put this plus in here and then deal with what's going on inside these brackets. Negative 2x times 2x equals negative 4x squared. For the same reason before, I am putting bracket here. Plus, negative 2x times 2 equals negative 4x. Plus, 2 times x squared equals 2x squared. Plus, 2 times 2x equals 4x. Plus, 2 times 2 equals 4. Now I am going to remove all the brackets by multiplying their sign. We get this. Now let's combine like terms. We know that like terms are terms having the same variable to the same power. First x power 4, which is not like to other terms. Next, plus 2x cubed minus 2x cubed. Plus 2x squared minus 4x squared plus 2x squared. Minus 4x plus 4x. Then the leftover plus 4. Now I write x power 4 as it is. Then here plus 2x cubed minus 2x cubed equals 0. It's like if I have two apples and I eat both of them, then I have no apple. Then plus 2x squared minus 4x squared equals minus 2x squared. And that minus 2x squared plus 2x squared equals 0. Then minus 4x plus 4x equals 0 and plus 4. Therefore, x power 4 plus 4. Summary. To put your new knowledge into practice, try the your turn questions below. This video is going to be all about polynomial expressions in algebra. In fact, these are your friends you have already met, but without being properly introduced. We will properly introduce them to you and they are going to be your friends in whatever mathematical journey you undertake from here on. A polynomial looks like this. That doesn't look very special, does it? We have seen a lots of algebraic expressions already, so why to bother about these? Factually, there are many reasons why polynomials are interesting and important in mathematics. Like, polynomials are extensively used in biology, computer science, communication systems, the list goes on. These pictures may be represented as a quadratic polynomial. So, polynomials are the mathematical expressions that include one or more parts, called terms. A term is just a number like the number 6, or a variable like x or y or a number multiplied by one or more variables, like 6 times x or 6x. Then, some polynomials have special names. A monomial, for instance, is just a polynomial with only one term. So the y you see here is a monomial, it has only one term. Same goes for this negative 3x and that 4y cube. Binomials are polynomials with two terms, like 3 plus 8x. And trinomials like 6 plus 3x plus x square have three terms. How do you remember the names? Think cycles: monocycle, bicycle, tricycle. Then most importantly, there are four restrictions that an expression is not a polynomial. First, the variable in each term cannot be a negative exponent. Second, the variable in each term cannot be a variable exponent. Third, the variable in each term cannot be in the denominator of a fraction. Fourth, the variable in each term cannot be inside a radical. So, simply, polynomial must have only non-negative integer exponents of variables. Or to put it more simply, variables' exponents must only be whole numbers. Okay, how do we get a polynomial? Well, here let's make one. Let's say we haven't been able to measure the garden, but we do know a little about its proportions. So we can assign variables to each side. To find the perimeter, we will need to add up all those sides. That is x plus 3y plus y plus y plus z. Simplify gets us 2x plus 5y plus z. That's a polynomial, alright, with three monomials added together. Adding, subtracting, multiplying and dividing polynomials is like we did it for expressions. We do the same things, there is nothing new. Okay, now let's try another polynomial. 3 times x square plus x times y cube is a polynomial. It's made of two monomials, so it's actually a binomial. Since it contains exponents, it has what's called a degree. You find the degree of a monomial by adding the exponents of the variables together. Remember that saying x is really the same thing as saying x to the first power. So that monomial has a degree of 4. The other monomial has a degree of 2. We can ignore that 3 because it's a constant, and we are only looking for the exponents of variables. To find the degree of a whole polynomial, you just find the term with greatest degree. That's your polynomial's degree. In this case, it's 4. Well, remember that a variable with no exponent is that variable to the first power. So if there are no exponents, the polynomial has a degree of 1. There are also special names for polynomials based on its degree. The degree of a constant is 0 because you can write, say, 7 as 7x power 0, which is just 7, since any non-zero number power 0 equals 1. Linear polynomial has degree 1, like 41x minus 7. Then, a polynomial of degree 2 is called quadratic polynomial, like square root of 5m square plus 4m minus 9. And a polynomial of degree 3 is called cubic polynomial. Example, y cube minus 6y plus 11. The standard form for writing a polynomial is to put the terms with the highest degree first. Example, let's put this polynomial in the standard form. 3x square minus 7 plus 4x cube plus x power 6. Here, the highest degree is 6, so that goes first. Then 3, 2 and then the constant term lost. So we have x power 6 plus 4x cube plus 3x square minus 7. You don't have to use standard form, but it helps. So formally speaking, an algebraic expression of the form p of x equals an x power n plus an minus 1 x power n minus 1 and so on up to a0 is called polynomial in one variable x of degree n, since which is the highest power. And then a0, a1, a2 up to an are constants. In that, an is not equal to 0 and n is a whole number. In general, polynomials are denoted by f of x, g of x, p of t, h of x, and so on.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the special products. Some binomial products have special forms that occur frequently in algebra. You don't need to memorize these formulas because you can use the distributive property to multiply. However, becoming familiar with these formulas will enable you to manipulate the algebra more quickly. Of those special products, let's see the geometrical proof of difference of two squares, a square minus b square. For that, take a square whose length of each side is a. Therefore, the area of the square is a square. Now, draw a square with the side of b at any corner of the square. So, the area of the small square is b square. Now, subtract the square whose area is b square from the square whose area is a square. It forms a new geometric shape and its area is equal to a square minus b square. Now divide the new subtracted geometric shape as two different rectangles, but the length of one of the two rectangles should be equal to b. Look at the upper rectangle. Geometrically, the length of this rectangle is a and its width is a minus b. Similarly, look at the lower rectangle. The length of this rectangle is a minus b and its width is equal to b. So, geometrically the width of the upper rectangle is a minus b and the length of the lower rectangle is also a minus b. If the lower rectangle is rotated by 90 degrees, then the widths of both rectangles become same and it is useful to join them together as a rectangle. So, first separate both rectangles, then rotate the lower rectangle by 90 degrees and then join both rectangles. It forms another rectangle. Now, as you can see, the length of the new rectangle is a plus b and its width is a minus b. Therefore, the area of the new rectangle is a plus b times a minus b. Or simply written as a plus b a minus b. Therefore, the areas of the both shapes should be equal geometrically. A square minus b square equals a plus b a minus b. In this video, we are going to see the geometrical proof of square of a binomial with positive sign. That is to say, a plus b the whole square. For that, firstly, take a square and divide it into two different parts vertically. The lengths of them are a and b. Similarly, divide the square horizontally with same lengths. So the widths of them are also a and b. The length and width of the square are same and the length of its each side is a plus b. We know that Generally, the area of the square is side multiplied by side. Here, this area of the square is a plus b multiplied by a plus b, which equals a plus b whole square. The geometrical procedure splits a square as 4 geometrical shapes, in which 2 of them are different squares and remaining 2 are 2 rectangles. Now let's calculate the area of each geometrical shape in mathematical form. The length of each side of red square is a, so its area is equal to a square. The length of blue rectangle is b and its width is a, so its area is equal to b times a or ba. Then the length of green rectangle is a and its width is b, so its area is equal to ab. The length of each side of yellow square is b, so its area is equal to b square. Now, let's add areas of all 4 geometrical shapes to express the whole area in mathematical form. We get a square plus ba plus ab plus b square. According to the commutative property of multiplication, the product of a and b is equal to the product of b and a. The equality of the areas of both rectangles can also be proved geometrically. Therefore, the term BA can be written as AB and vice versa. So, A square plus AB plus AB plus B square. And we know that 1AB plus 1AB equals 2AB. So we get A square plus 2AB plus B square. In this video, we have come across that the area of the square is equal to a plus b whole square in the first step. In the second step, it is proved that the sum of the areas of 4 geometric shapes is equal to a square plus 2ab plus b square. Actually, a square is divided as 4 geometrical shapes. It is obvious that the area of the square is equal to the sum of the areas of them. Geometrically, it is proved that the square of a plus b can be expanded as a square plus 2 times product of a and b plus b square. In our previous videos, we learned that geometrical proofs of some special products. In this video, we are going to see the geometrical proof of a minus b the whole square. Take a square and assume the length of each side of this square is a. We have to calculate the area of this geometric shape mathematically. According to the mathematics, the area of a square is equal to the square of the length of the side. In this case, it is taken that the length of each side is equal to a. Therefore, the area of this square is equal to a square. For proving the a minus b whole square formula geometrically, we have to split the square as 4 different geometrical figures. First, draw a line vertically across the pair of opposite sides for dividing the square as 2 rectangles. If the length of one rectangle is denoted by b, then the length of remaining rectangle will be a minus b. Now, divide the both rectangles horizontally by drawing a straight line such that the width of 2 shapes are equal to b. Then the widths of remaining 2 shapes are equal to a minus b. It is useful for creating a square whose area is equal to a minus b whole square. Geometrically, we have successfully divided a square as 2 small squares and 2 rectangles. Now let's calculate the area of each geometrical shape mathematically. The length of each side of yellow square is a minus b. Then its area is equal to a minus b whole square. The length of blue rectangle is b and its width is a minus b. Then its area is equal to b times a minus b, or which can be written as b of a minus b simply. The length of red rectangle is a minus b and its width is b. Then its area is equal to a minus b times b, which is simply written as a minus b of b. The length of the green square is b, therefore its area is equal to b square. Thus, the areas of all geometrical shapes are calculated and expressed in algebraic form. It is time to prove the expansion of a minus b whole square formula geometrically. Geometrically, a square is divided as 4 different geometrical shapes. So, the area of the square is equal to the sum of the areas of 4 geometrical shapes. It can be written in mathematical form as an equation, that is, a square equals a minus b the whole square plus b times a minus b plus a minus b times b plus b square. Here we have to find a minus b the whole square. So shift all the terms to other side of the equation for finding the equivalent value of a minus b whole square. By doing so we get a square minus b times a minus b minus a minus b times b minus b square, which equals a minus b the whole square. Now swap sides. In the right hand side, ba minus b and a minus bb are equal as per commutative property of multiplication. So we can write a minus bb as ba minus b and vice versa. So we get a minus b the whole square equals a square minus ba minus b minus ba minus b minus b square. We know that minus 1 ba minus b minus 1 ba minus b equals minus 2b a minus b. Now, if you distribute the minus 2b to each term inside the bracket, we get a minus b the whole square equals a square minus 2ba plus 2b square minus b square. Therefore, a minus b the whole square equals a square minus 2ab plus b square. Since we can write ba as ab, again as per commutative law of multiplication, then we know that plus 2b square minus 1b square equals plus 1b square. So, here are the 3 results we just got from our previous videos. One is the difference of squares or sum and difference of same terms. Others are the square of a binomial. Remembering those patterns will save our time and help us solve many algebra puzzles. So a sum and a difference pattern means that you have one that's added, one that's subtracted. But notice that the a and the b in the first binomial are the same as the a and the b in the second binomial. Now we know the distributive property. Let me just show you that real quick. So if we distribute the a, we get a square. Now if we distribute a to the negative b, we get negative a times b or ab. And then we get plus b times a or ba. And then negative b square. But what you will notice is, see the negative ab and the positive ba. Those are the same terms, so one is negative, one is positive. They cancel. And you can see we are left with a square minus b square. So when you see a pattern like this, all you have to do is multiply the first terms together and the last terms together. You don't have to worry about the inner product and the outer product because those are going to cancel out. We are going to do some examples, you will see how that works. The second type we are going to work with is the binomial square. So remember, binomial means 2 terms and it's the quantity raised to the second power. Now another way to do these problems if you wanted, of course what I am trying to show you here in this video is the shortcut, is when you square something, it means that you have 2 of that quantity, right? So what you can do is, you can distribute this out. But I am going to show you how you can do this a little bit quicker. So a times a is a square, a times b gives us ab. B times a gives us ba or ab again. And then b times b gives us b square. And you can see that ab plus ab is 2ab. So we are going to talk about a quicker way of doing it. Is you take a the first term square, you take the b, that's the second term square. But to find the middle term, you multiply a times b and then you double it or multiply it by 2. Now what's interesting is that if you are adding this, is going to be addition or positive. But if you are subtracting this, is going to be subtraction or a negative. So far we have just used a and b, but they could be anything. And a very common error you people think it's just this one square plus this one square. And it's not, you know. Let's try this with the actual numbers here. If you did 5 plus 2 the whole square, I will show you that it doesn't equal 5 square plus 2 square. 5 plus 2 is 7, 7 square is 49. That doesn't equal 5 square plus 2 square, which is actually 29. And then over here, if you do 5 minus 2 is 3, 3 square is 9. And that doesn't equal 5 square minus 2 square or 25 minus 4. So what we have got to do, we need to, when we have a binomial square, this is the correct way to do it. So example number 1. You have got 5x plus 9 times 5x minus 9. We notice that this is a sum and difference pattern. A and b are the same. So we know all we have to do is multiply the first term in this group and the first term in that group, which gives us 5x the whole square. Here this bracket is very important since the square is for both 5 and x. Suppose if you don't put the bracket, it will mean square is only for x. So when squaring the number and letter together, we must put the bracket. Then minus the last term times the last term, that's 9 square. And remember what I told that sum and a difference of same two terms has no middle term. Okay, let's start simplify now. In this case, since there is multiplication between 5 and x, we can just distribute this square straight to both 5 and x without thinking about anything. By doing so, we get 5 square is 25, and if we square the x, we get x square minus 9 square or 9 times 9 is 81. And that's it. We are done. Of course, you can distribute it out, but this is a time saver, right? So let's look at example number 2. Now this one again, we have got a sum and difference. Oops. Okay, here we got a difference and sum. Actually, as far as this case is concerned, both sum and difference and sum are same. You know why? Because there is a multiplication sign between them. And remember that multiplication is commutative. Okay, here we got a difference and sum. A and b are the same. 2x and 1, right? So we have got 2x times 2x, which is 2x the whole square, minus 1 times 1 is 1 square. So we have 2 square is 4, and if we square the x, we get x square, minus 1 square is 1. And that's it. Okay, number 3. Same thing, a sum and a difference pattern. A and b are the same. CD and 8. So we have got CD times CD is CD the whole square, minus then 8 times 8 is 8 square. So that is C times C is C square and D times D is D square, minus 8 square is 64. Now let's take a look at 2x plus 3 the whole square. This is a binomial square with the positive sign. It is the same thing times itself twice, right? So we are going to use this pattern over here. We have got the first term square, which is 2x the whole square. The last term square, which is plus 3 square. But to find the middle term, we multiply the 2x and 3 and double it or multiply it by 2. So 2x the whole square is 4x square plus 2 times 2x is 4x and that 4x times 3 is 12x plus 3 square is 9 and you got it. Okay, let's try another one. This one you are subtracting, so same pattern you can see it's a binomial square with negative sign. We have got the first term square, which is 5y the whole square. Then the last term square, which is plus 4 square. Here notice that I didn't write negative sign because of the pattern of the binomial square. And to find the middle term, we multiply 5y and 4 and double it. Here is the binomial square with negative sign, so our middle term should be negative. So 5y the whole square is 25y square minus 2 times 5y is 10y and that 10y times 4 is 40y plus 4 square is 16. Sometimes we can see the pattern of the answer. Example, which binomials multiply to get 4x square minus 9? Is that the difference of two squares? Yes. We can write 4x square as 2x the whole square and 9 as 3 square. Here, to check whether we have rewritten it right or not, just go reverse. And if we end up with the original question, we can conclude that we have done the right thing. So, I am going to distribute the power 2 to the base 2. We get 4. And if we distribute the power 2 to the base x, we get x square. Everything is perfect. By the way, you can use just go reverse method in mathematics when you're not sure what you have done. So we have 4x square minus 9 equals 2x the whole square minus 3 square. And that can be produced by the difference of squares formula. Like this, a is 2x and b is 3. So we get 2x plus 3 times 2x minus 3. So the answer is that we can multiply 2x plus 3 and 2x minus 3 to get 4x square minus 9. Now let's evaluate or to calculate the value of 37 square minus 24 square divided by 37 plus 24. Is that the numerator the difference of two squares? Yes. Like this, a is 37 and b is 24. So by using the difference of two squares, we can write 37 square minus 24 square as 37 plus 24 times 37 minus 24 divided by 37 plus 24. Now there is a good thing for us. We can cancel out the 37 plus 4 in the numerator and the denominator because we have a license to cancel them. I mean, there is a multiplication between them. So we have 37 minus 24 is 13. Here, let's find the product of x plus y plus 2 and x plus y minus 2. The first time you see it, it may seem to you that this is not what we have learned before, right? Because there is trinomial products. But we surely know one thing by seeing this, there is only one difference. Here plus, there minus. Rest are same. So, I am gonna group x plus y in brackets. Consequently, we can write the product of the trinomials as a special product. So we have got a sum and difference pattern a and b are the same. X plus y and 2, right? So we have got x plus y times x plus y, which is x plus y the whole square, minus 2 times 2 is 2 square. So we have x plus y the whole square is like a plus b the whole square. So x square plus 2xy plus y square minus 2 square is 4. And that's the product of x plus y plus 2 and x plus y minus 2. Algebra is a language. In many ways, mastering algebra is just like learning French, Tamil, Italian, or maybe even Japanese. To understand algebra, you need to learn how to read it and how to change plain English into math talk and math talk back into plain English. And some people call it as puzzles. Yes, with algebra, you get to find secret things. And when you learn some of the tricks, algebra becomes a fun challenge to work out how to use your skills in solving each question. Okay, let's start with a puzzle. What is the missing number here? The answer is 8, right? Because 8 minus 3 equals 5. Easy stuff. Well, in algebra we don't use blank boxes. We use a letter, usually a x or y, z. But any letter is fine. So we write x minus 3 equals 5. It is really that simple. The letter in this case an x just means we don't know this yet and is often called the unknown or the variable. And when we solve it, we write x equals 8. We can understand from that, oftentimes algebra substitute letters or variables for unknown values. That's why I said in the beginning, algebra is get to find secret things. Back to the same puzzle. Instead of saying obviously x equals 8, how to use the neat step-by-step approach? Let's learn that now. Generally, the very first thing is to do when we get to solve a puzzle or equation, isolating the variable on one side of the equation, here x, and remove whichever next to the variable, here minus 3. So we want to remove the minus 3. To remove it, do the opposite. In this case, add 3. Do it on both sides. Which is x plus 0 equals 8.
Why did we add 3 on both sides? Just to keep the balance. If I add 3 to left side, it will be out of balance. To make it balance again, we have to add 3 to right side also. So, to keep the balance, what we do to one side of the equation, we should do to the other side. Let's solve this equation now. What we want is an answer like x equals some number. But the plus 2 is in the way of that. We can cancel out the plus 2 with a minus 2 because plus 2 minus 2 equals 0. So let us have a go at subtracting 2 from both sides. Which means x equals 7 minus 2. Therefore x equals 5. Let's have another puzzle. What is the missing number here? The answer is 2, right? Because 3 times 2 equals 6. Well, in algebra we don't use blank boxes. We use a letter. So we would write 3 times x equals 6. But the x looks like multiplication symbol. That can be very confusing. So in algebra we don't use multiplication symbol between numbers and letters. We put the number next to the letter mean multiply. So the answer is x equals 2. Let's solve another equation. That is 3x equals 6, or we can say 3 multiplied by x equals 6. But before that, what is the opposite of multiplying? Dividing, right? What we want is an answer like x equals some number. We want to remove the 3. To remove it, do the opposite. In this case, divided by 3. Just do it on both sides. Which is 1 times x equals 2. 1 times x is nothing but x equals 2. Let's solve this one. X divided by 4 equals 6. What we want is an answer like x equals some number. But the divided by 4 is in the way of that. If we multiply by 4, we can cancel out the divided by 4 because 4 divided by 4 equals 1. So let's try multiplying by 4 on both sides. We can cancel out 4 in the numerator and 4 in the denominator. So x equals 6 times 4. Therefore x equals 24. Summary. To put your new knowledge into practice, try the your turn questions below. In this video, we are going to learn transpose method. It's another way to solve equations. Let's take a balance with two pans. This pan has 2 3 kgs and this pan has 1 6 kg. Now let me remove 1 3 kg from on one pan here, but on the other pan I have only a 6 kg weight. How I remove 3 kg from here? I can make a 3 kg hole in the 6 kg weight. So one way to imagine it, when I took 1 3 kg to the other side, instead of it remaining a weight, it became a hole. I repeat, instead of being a weight, it became a hole. What am I trying to say here? Mathematically, if you think of it, what happened? If it had a 3 kg weight here, it was plus 3. If it had a hole here, it was minus 3. Because I removed the weight, right? So when you have plus 3 and want to take it to the other side, it becomes minus 3. It is as same as the balancing method. One way to imagine it, subtract 3 on both sides. Another way to say the same thing is, when you take plus 3 from one side to the other side, it becomes minus 3. Ultimately, we are doing the same thing. Let's solve this equation. In other words, to find the value of the variable y. To solve this equation in balancing method, we usually add 8 on both sides to remove minus 8. Instead of doing that, let's solve this equation in transpose method. In order to solve any equation in transpose method, we have to hold the term on one side of the equation that we want to find, that is mostly variables, and get rid of all the other terms to another side of the equation. Here, hold the y and let's bring the minus 8 to the other side. So y equals, now you have to write first whatever already on this side, that is 16. And when I take minus 8 to the other side, it crosses the equal sign, it becomes plus 8. Thus, y equals 24. Let's solve this equation now. Here we have two terms. One is 2z or 2 times z, and 5 is nothing but plus 5. Here we have to hold the 2z, so let's bring the 5 to the other side. So 2z equals 15 and the plus 5 becomes minus 5. We get 2z equals 10. We need z value, not 2z. So we have to get rid of the 2. But how? Just like the previous step, when you have plus 5 and you want to take it to the other side of the equation, it becomes minus 5. Similarly, when you have multiplication on one side of the equation and you want to take it to the other side, it becomes division. So let's bring the 2 times to the other side. By doing so, we get z equals 10 divided by 2. If we strike the numerator and the denominator by 2 table, we get z equals 5. Another equation. Here we have two terms. Let's hold the x term and bring the plus 3 to the other side. So x by 2 equals 5 minus 3, which means x by 2 equals 2. We need to find the value of x, not x by 2. So get rid of the division 2 to the other side, it becomes multiplication of 2. We get x equals 2 times 2. Therefore, x equals 4. Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the equation and the formula. An equation says that two things or expressions are equal. It will have an equal sign like this. That equation says what is on the left, that is x plus 7, is equal to what is on the right, that is 9. So an equation is like a statement, this equals that. Notice that this equation has the solution x equals 2. And you know that how to solve this equation and the equations like this if you have watched our previous videos. Formula. A literal equation is an equation that contains more than one variable. A formula is an example of a literal equation. Many common types of geometric, scientific, and investment problems use ready-made equations called formulas. Knowing these formulas will help you translate and solve a wide variety of real-life applications. Formula shows us how things are related to each other. Example: The formula for finding the volume of a box is V equals LWH. V stands for volume, L for length, W for width and H for height. When L equals 10, W equals 4 and H equals 5, then the volume of the box V equals 10 times 4 times 5, which equals 200. Subject of a formula. The subject of a formula is the single variable, usually on the left of the equal sign that everything else is equal to. Example. In the formula A equals half BH, A is the subject of the formula. These are all equations, but only some are formulas. Remember I told you, formula shows us how things are related to each other. Here in the first equation, x and y are related, so it's a formula. In the second equation, a, b and c are related to each other, so it is also a formula. But in the last equation, there is no variable relation with x, so it is just an equation, not a formula. Changing the subject. A very powerful thing that algebra can do is to rearrange a formula so that another variable is the subject. Example. Let's rearrange the volume of a box formula V equals LWH so that the width is the subject. Start with V equals LWH. Divide both sides by h. We get V over h equals LW. Now, divide both sides by L. By doing so, we get V over HL equals W. Swap sides. Therefore, W equals V over HL. So if we want a box with a volume of 12, a length of 2 and a height of 2, we can calculate its width. Let us use the formula we rearranged a while ago, which is W equals V over HL. If we substitute the value of V, H and L, we get 12 over 2 times 2, which means 12 over 4. Therefore, the width of the box is 3. Summary. To put your new knowledge into practice, try the your turn questions below. Hi. Let's learn about the solving linear equations with one variable. These are all linear equations. Well, a linear equation is an equation that has degree 1. Remember that a variable with no exponent is that variable to the first power. So if there are no exponents, the equation has a degree of 1. So again, these are all linear equations. For now, we will set aside these equations because in this video we are going to see about solving equations with one variable. Generally, when solving an equation, our aim is to isolate the variable on the left of the equal sign. Something like x equals 13 and y equals negative 11. That means we solved. There are 3 simple steps to solving an equation with one variable. Step 1. Simplify each side of the equation using the order of operations. It's like removing brackets using distributive law and combine like terms. Simplifying each side of the equation is a two-step process. First simplify the left-hand side, next simplify the right-hand side. Step 2. Isolate all the variable terms to one side of the equation and move all the numbers to the other side. Step 3. Multiply or divide both sides of the equation by the same number. With that in our mind, let's start solving this equation. 6x plus 3 plus x equals negative 18. Step 1. Simplify each side of the equation using the order of operations. It's like removing brackets using distributive law and combine like terms. There are no brackets on both sides, but we can combine the like terms 6x and x. We get 7x plus 3 equals negative 18. Now step 2. Isolate all the variable terms to one side of the equation and move all the numbers to the other side. Here I can see the only one variable term 7x. So let's hold the 7x and bring this plus 3 to that side. We get 7x equals, here first write whatever already on this side, that is negative 18. And if we bring this plus 3 to that side, it becomes minus 3. Consequently, we get 7x equals, and this negative 18 minus 3 is negative 21. So we done it all the variable terms to the one side of the equation and all the numbers to the other side. So let's move on to the step 3. Multiply or divide both sides of the equation by the same number. Here what we want is an answer like x on its own on the left of the equal sign. But the multiplication of 7 is in the way of that. Why I say that's because 7x is actually 7 times x. So to remove it, do the opposite. In this case, divided by 7. Just to keep the balance, do it on both sides. So 7 divided by 7 is 1, and that 1 times x is just x. Negative 21 divided by 7 is negative 3. So our solution is x equals negative 3. A solution is a value we can put in place of a variable that makes the equation true. Here our solution is negative 3. We could check by putting the value negative 3 in place of x in the original equation. If the two sides of the equation are equal, then our answer is correct. Okay, to check, substitute negative 3 for x. We get 6 times negative 3 plus 3 plus negative 3. Here, we should not write more than one sign back to back like this. We have to differentiate them with brackets. Equals negative 18. So 6 times negative 3 equals negative 18, then plus 3, and a positive times a negative equals a negative 3, equals negative 18. Now let's consider first two numbers. Negative 18 plus 3 is negative 15. And that negative 15 minus 3 is negative 18. So our answer is correct. Now let's solve in another example. Negative 3 times 2x plus 2 equals 6. Step 1. Simplify each side of the equation using the order of operations. It's like removing brackets using distributive law and combine like terms. So the first thing I always want to do if I see it is distribute. That negative 3 outside of a bracket means I need to distribute it. Negative 3 times 2x is negative 6x. Negative 3 times positive 2 is negative 6. And now I am just bringing down anything I didn't use, that is equal 6. Now I am looking for combining the like terms, but there are no like terms on this side and there are no like terms on that side. So let's move on to the step 2. Isolate all the variable terms to the one side of the equation and move all the numbers to the other side. Here I can see the only one variable term, that is negative 6x. So let's hold the negative 6x and bring this minus 6 to that side. We get Negative 6x equals, here first write whatever already on this side, that is 6. And if you bring this minus 6 to that side, it becomes plus 6. By doing so we get negative 6x equals 12. So we done it all the variable terms to the one side of the equation and all the numbers to the other side. So let's move on to the step 3. Multiply or divide both sides of the equation by the same number. Here what we want is an answer like x on its own on the left of the equal sign. But the multiplication of negative 6 is in the way of that. Why I say that's because negative 6x is actually negative 6 times x. So to remove it, do the opposite. In this case, divided by negative 6. Because negative 6 divided by negative 6 is 1. Just to keep the balance, do it on both sides. So, negative 6 divided by negative 6 is 1 and 1 times x is just x. 12 divided by negative 6 is negative 2. So, our solution is x equals negative 2. Here, 4y minus of 2y minus 3 equals 0. Step 1. Simplify on both sides, like removing brackets using distributive law and combine like terms. So I'm gonna go ahead, distribute this negative, each term inside of my bracket. First I just copy the 4y which I didn't use. Then for the sake of simplicity, we can consider a negative sign as negative 1. So negative 1 times 2y is negative 2y and negative 1 times negative 3 is positive 3, which equals 0. So I have distributed, now I am looking to combine like terms. So the only like terms I see here are 4y and negative 2y. 4y minus 2y is 2y and plus 3 equals 0. Now step 2. Let's isolate the y term on the left of the equal sign and bring this plus 3 to that side. By doing so we get 2y equals 0 minus 3 or just negative 3. So we done it all the variable terms to the one side of the equation and all the numbers to the other side. So let's move on to step 3. Here what we want is an answer like y on its own on the left of the equal sign. But the multiplication of 2 is in the way of that. So to remove it, do the opposite. In this case, divided by 2. Just to keep the balance, do it on both sides. So 2 divided by 2 is 1 and that 1 times y is just y. And we cannot divide negative 3 by 2, so leave it as it is. Therefore our solution is y equals negative 3 over 2. Now let's solve this one. 5 times x minus 2 equals 3 times 2x plus 1. So, step 1, which says that firstly remove the brackets by distributive law and combine like terms. So the first thing I always want to do if I see it is distribute. That 5 and this 3 outside of a brackets mean I need to distribute it. On the left side, 5 times x is 5x. And 5 times negative 2 is negative 10 equals, now I distribute the 3 inside the bracket. So 3 times 2x is 6x and 3 times positive 1 is positive 3. Okay, so far so good. Now I am looking to combine like terms. But there are no like terms on this side and there are no like terms on that side. So let's move on to step 2. Which says that isolate all the variable terms to one side of the equation and move all the numbers to the other side. I can see the only one variable term on the left hand side is 5x and on the right hand side is 6x. So I am going to isolate the variable terms 5x and 6x on the left hand side of the equation and the numbers negative 10 and plus 3 on the right hand side by bringing 6x to the left side and bringing negative 10 to the right side. Here, first write whatever already on this side, that is 5x, and then write the newcomer. I mean, if I bring this plus 6x to this side, it becomes minus 6x equals. Again, here first write whatever already on this side, that is plus 3 or just 3. Usually we don't write plus sign before the number when we start. And if we bring this minus 10 to that side, it becomes plus 10. So 5x minus 6x is negative 1x or just negative x equals 3 plus 10 is 13. Now step 3. Here what we want is an answer like x on its own on the left of the equal sign. But the multiplication of negative 1 is in the way of that. So to remove it, do the opposite. In this case, divided by negative 1. Just to keep the balance, do it on both sides. So negative 1 divided by negative 1 is 1, and that 1 times x is just x. And 13 divided by negative 1 is negative 30. Hence, our solution is x equals negative 13. The last one of this video, 3y over 2 equals y over 4 plus 2. Step 1. There are no brackets and no like terms on both sides. So let's move on to step 2. Isolate all the variable terms to one side of the equation and move all the numbers to the other side. I can see the variable y terms on both sides, so that I'm going to isolate them on the left hand side of the equation by bringing this y over 4 to that side. By doing so we get, here first write whatever already on this side, that is 3y over 2. And if I bring this y over 4 to that side, it becomes minus y over 4, then equals 2. Now let's use the cross multiplication to combine these two. If you need a refresher, see adding and subtracting rational numbers with different denominators. Well, cross multiplication method for adding and subtracting rational numbers says that put the big divide first. Then multiply the bottom of the second number by the top of the first number. That is 4 times 3y is 12y. Next write the sign in between, whatever it be, here minus. Then multiply the bottom of the first number by the top of the second number. That is 2 times y is 2y. After that, multiply the bottoms together. That is 8. And just copy the right side. Now 12y minus 2y is 10y. Divided by 8 equals 2. So we can cancel the top 10 and bottom 8 by the common factor 2. We get 5y over 4 equals 2. So we done it all the variable terms to the one side of the equation and all the numbers to the other side. So let's move on to step 3. Here, what we want is an answer like y on its own on the left of the equal sign. But the multiplication of 5 over 4 is in the way of that. So to remove it, do the opposite. In this case, divide by 5 over 4. Well, divided by 5 over 4 means the multiplication of the reciprocal of 5 over 4. That is 4 over 5. Just to keep the balance, do it on both sides. And we know that if there is a multiplication sign between two rational numbers, we have a license. We can go and cancel the bottom of the one rational number to the top of the another rational number. As we all learned that in the video, namely multiply the rational numbers. So we can cancel 5 and 5, then 4 and 4. So 1 times y is just y. Then on this side, for the sake of simplicity, I can write this 2 as 2 over 1. And we know how to multiply the two rational numbers, that is, multiply the tops together and multiply the bottoms together. So 2 times 4 is 8, 1 times 5 is 5. Therefore our solution is y equals 8 over 5. Summary. To put your new knowledge into practice, try the your turn questions below. In this video, we are going to see cross multiplication method to solve equations or proportions. Actually, we have seen earlier a cross multiplication method which is for adding and subtracting rational numbers. However, this is for solving equations or proportions which helps us to save our time. Okay, to cross multiply is to go from this to this. Yeah, I know what you're thinking now. How does it work, right? Before we getting into this, remember that multiplying the numerator and the denominator of a rational number by the same amount doesn't change its value. Now let's see how I got from this to this. First, multiply the numerator and denominator of the first rational number by the denominator of the second rational number. By doing so, we get this. 5 times 12 over 6 times 12. Then multiply the numerator and denominator of the second rational number by the denominator of the first rational number. We get 10 times 6 over 12 times 6. Right now, as you can see, there is a good thing for us. The denominator of the both rational numbers are same. So we can cancel them as we are dividing both sides by the same amount and the equation is still true. That's it. Our job is done. In practice, though, it is easier to skip the steps and go straight to the cross multiplied form. So in general, to cross multiply is to go from this A over B equals C over D to this A times D equals C times B. Now let's see some examples using cross multiplication method. Here we can cross multiply anytime we have one rational number making up the left side equal to another rational number making up the right side. Now to cross multiply, we literally cross over, we take the denominator of one side and we multiply with the numerator on the other side. So in this case, we have 9 times 3. Then we repeat on the other side, we take the 4 which is in the denominator and we cross multiply with the numerator x. So we have 4 times x. After simplifying we have 27 equals 4 times x is 4x. Now I'm going to swap sides because we usually keep the variable term on the left of the equal sign. We get 4x equals 27. Okay. Here what we want is an answer like x on its own on the left of the equal sign. But the multiplication of 4 is in the way of that. So to remove it, do the opposite. In this case, divided by 4. Just to keep the balance, do it on both sides. So 4 divided by 4 is 1 and that 1 times x is x. Here we cannot divide 27 by 4, so leave it as it is. Hence our solution is x equals 27 over 4. Now let's see another example. X minus 5 whole divided by 5 equals 3 over 8. Some people might think we can cancel this denominator 5 and the numerator 5, but factually you can't. Because we don't have license to cancel them, I mean there is no multiplication sign between x and 5. So what we can do here, cross multiply, since one rational number form equals another rational number form. Cross multiplication method lets us to do that. We take the denominator of one side and we multiply with the numerator on the other side. So we have 8 times x minus 5. If we write like this, it is totally wrong. It means 8 is only for x, but actually it is not so. 8 is for both x term and negative 5. For that, we have to keep the bracket for the expression that having more than one term. So the bottom of the line, when we are multiplying two things, we must keep the bracket for the expression having more than one term. Okay, here if we take the 5 which is in the denominator and we cross multiply with the numerator 3, we have 5 times 3 is 15. Now like solving a linear equation with one variable. Step 1. Simplify on both sides. Like removing brackets using distributive law and combine like terms. So I'm gonna go ahead and distribute this 8 to each term inside of my brackets. So 8 times x is 8x and 8 times negative 5 is negative 40, which equals 15. Now step 2. Isolate all the variable terms to one side of the equation and move all the numbers to the other side. Here I can see the only one variable term, 8x. So let's hold the 8x and bring this negative 40 to that side. We get 8x equals, here first write whatever already on this side, that is 15. And if we bring this negative 40 to that side, it becomes plus 40. Consequently, we get 8x equals 55. Now step 3. Multiply or divide both sides of the equation by the same number. Here what we want is an answer like x on its own on the left of the equal sign. But the multiplication of 8 is in the way of that. So to remove it, do the opposite. In this case, divided by 8. Just to keep the balance, do it on both sides. So 8 divided by 8 is 1 and 1 times x is x. Hey, we cannot divide 55 by 8, so leave it as it is. Hence our solution is x equals 55 over 8.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the coordinate plane. Graph is just a visual method for showing relationships between numbers. Example, to convert data to a graph from a table of values like this one, you need to know about coordinate planes. A plane is a flat surface with length and width, but no depth. In other words, it has 2 dimensions instead of 3, and it has no edges, sort of like a piece of paper that goes on forever. A coordinate plane is a plane overlaid with 2 perpendicular number lines. Those lines help you find any point on the plane. It's also known as a Cartesian plane, after René Descartes, the guy who developed the idea way back in 1637. Basically, he drew 2 perpendicular lines in the middle of a plane and called the place where the lines intersect the origin. One line represents the horizontal distance from the origin. We call that the x-axis. The other line represents vertical distance from the origin, that is called the y-axis. These lines help us find our way around the plane. Well, everything starts from the origin. The coordinates or the address of the origin are 0, 0. That means to find the origin, you have to move 0 units horizontally and 0 units vertically. The set of numbers that describes a point is called an order pair, because the order of the numbers matters. For instance, 3, 4 is different from 4, 3. The first number tells you the address of a point on the x-axis, while the second number tells you the address of a point on the y-axis. So, to find the point described by the order pair 3, 4, you would start by looking at the first number, the x-coordinate. It tells you to go 3 units to the right. Next, you look at the second number, the y-coordinate, which tells you to go 4 units up. Now it's at the point 3, 4. But if you were finding the point described by the order pair 4, 3, you would start out by 4 units to the right and 3 units up. Those are in totally different places. Each section of the coordinate plane is called a quadrant because there are 4 of them and they are numbered in a counterclockwise direction. You can always predict what quadrant a point will fall in by looking at the positive and negative numbers. Quadrant 1 has all the points with a positive x coordinate and a positive y coordinate, like 3, 2. Quadrant 2 has all the points with a negative x coordinate and a positive y coordinate, like negative 3, 2. Quadrant 3 has all the points with a negative x coordinate and a negative y coordinate, like negative 3, negative 2. And quadrant 4 has all the points with a positive x coordinate and a negative y coordinate, like 3, negative 2. You can remember that x comes first because, well, x comes before y in the alphabet.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the graphing linear equations. In our previous videos, we learned to solve any linear equations with one variable. In this video, we are going to see how to graph linear equations with two variables. Graphing is a good way to visualize what happens when you plug different numbers into an equation. Well, an equation is a comparison of two sets of numbers with an equal sign, like 24 equals 4 times 6. A linear equation is sort of like that, only we don't know all of the numbers. We use placeholders called variables to represent these unknown amounts. Any letter you see inside an equation is a variable. X and Y are used a lot, but you can really use any letter you want. Then, a linear equation is an equation whose graphical form is a straight line. Many linear equations are also functions. They describe the relationship between an output value y and an input value x. Functions? We will learn about them later. Okay, here, to graph a linear equation, find and plot at least 2 points that make the equation true, and connect these points into a straight line. Okay, to graph a linear equation, follow these 4 simple steps. Step 1. Solve the equation for y, which means isolate the y on the left hand side of the equal sign. Step 2. Find at least 2 points that make the equation true. Step 3. Graph the 2 points. Step 4. Connect the 2 points into a straight line. Make sure to extend the line with arrows to show that it goes on forever. Now let's graph this linear equation. 2 plus x minus y equals 0. How can I say it's a linear equation? Because the maximum power of any variable is 1 and it has two variables x and y. Step 1. Solve the equation for y. That means isolate the y. If we bring this negative y to that side, it becomes positive y. So we have 2 plus x equals 0 plus y or just y. Now I am going to swap sides because the step 1 says that put y on the left of the equal sign. We get y equals 2 plus x. And let's label this equation as the number 1 because we are going to use this equation often. Okay, we isolated the y on the left of the equal sign. So we move on to step 2. Find at least 2 points that make the equation true. So pick 2 random numbers for x. Say 0 and 3, and with these values, let's see what we get for y. If we put 0 in place of x in our altered equation 1, it becomes y equals 2 plus 0. So we have y equals 2. So the order pair form, in other words, the point is 0, 2. 0 is the x value and 2 is the y value. Then if we give 3 in place of x in the equation 1, it becomes y equals 2 plus 3. So we have y equals 5. So our second point is 3, 5. The points 0, 2 and 3, 5 make the equation 1 true. We found the points, so let's move on to step 3. Graph the 2 points. Well, now we can use our trusty coordinate plane, a two-dimensional representation of space. That space is split up by an x-axis and a y-axis. And those axes correspond to the x and y from our equation. We can use the x and y values from our equation to map points on the plane. Check it out. We have a point 0, 2. So, to find the point described by the order pair 0, 2, you would start by looking at the first number, the x coordinate 0. It tells you to stay there. Next, you look at the second number, the y coordinate, which tells you to go 2 units up. Now it's at the point 0, 2. In the same way, let's find the point 3, 5. You would start out by going 3 units to the right and then 5 units up. Now step 4. Connect and extend the 2 points to make a straight line. Now we have got 2 points graph out, and since linear equation graph a straight lines, 2 points is really all we need. So this is the graph of the linear equation 2 plus x minus y equals 0. It looks like a simple graph, but there are many things we can infer from it. First, the graph is a straight line. The graph of a linear equation will always be a straight line. No matter what linear equation you pick, the graph will always be a straight line. What else does this graph tell us? Another important thing it tells us is that whichever point you pick on in this line, it will be a solution to this equation. Now these 2 points will surely no other solution of this linear equation. So let's take another random point, say this one, 2, 4. When x is 2 and y is 4, we say that the equation is satisfied. 2 plus 2 is 4 and that 4 minus 4 is 0. We get left hand side equals right hand side. So whichever point you take on this line, it will be a solution to our linear equation. And is there anything else you can deduce from this concept? Absolutely, if you pick a point which does not lie on the line, it will not be a solution to this equation. Take any random point which does not lie on this line. Say at this point 1, 2, it will not be one of the solutions of this equation as it does not lie on the line. And we can also verify it mathematically. 2 plus 1 is 3 and that 3 minus 2 is 1, not 0. Now you know how to plot the graph of a linear equation in two variables. And apart from that, there are 3 main takeaways from this video. First, the graph of a linear equation will always be a straight line. Second, every point on the line will be the solution of the equation which shows the line. And third, every point which does not lie on the line will not be a solution of the linear equation which shows the line. Now let's graph another linear equation 3x plus y equals 2. Step 1. Solve the equation for y. That means isolate the y. So let's isolate this y on the left by bringing this positive 3x to that side. By doing so we get y equals, here first write whatever already on this side, that is 2. And if we bring this plus 3x to that side, it becomes minus 3x. And let's label this equation as the number 1 because we are going to use this equation often. Okay, we isolated the y on the left of the equal sign. So let's move on to step 2. Find at least 2 points that make the equation true. So pick 2 random numbers for x. Say -1 and 1, and with these values, let's see what we get for y. If we put -1 in place of x in our equation 1, it becomes y equals 2 minus 3 times -1. So we have y equals 2, then -3 times -1 is positive 3. We get y equals 5. So the order pair form, in other words, the point is -1, 5. -1 is the x value and 5 is the y value.
Then if we give 1 in place of x in the equation 1, it becomes y equals 2 minus 3 times 1. So we have y equals 2 minus 3 times 1 is 3. We get y equals 2 minus 3 is negative 1. So our second point is 1, negative 1. The points negative 1, 5 and 1, negative 1 make the equation 1 true. We found the 2 points, so let's move on to step 3. Graph the 2 points. We have a first point negative 1, 5. So, to find the point described by the order pair negative 1, 5, you would start by looking at the first number, the x coordinate, negative 1. It tells you to go 1 unit left. Next, you look at the second number, the y coordinate, which tells you to go 5 units up. Now it's at the point negative 1, 5. In the same way, let's find the point 1, negative 1. You would start out by going 1 units to the right and then 1 units down. Now step 4. Connect and extend 2 points to make a straight line. Now we have got 2 points graph out, and since linear equation graph is straight lines, 2 points is really all we need. So this is the graph of the linear equation 3x plus y equals 2. Summary. To put your new knowledge into practice, try the your turn questions below. Hi, let's learn about the slope and y-intercept form. The slope of your line is another word for its steepness. This mountain, for example, is really steep. In mathematics, slope is just a measure of how something changes vertically or up and down, compared to how it changes horizontally or left and right. Well, to find the slope of your line, you have got to look at 2 or more of its points. The line of this mountain can be thought of as a series of points that are connected. The best way to visualize this is with a coordinate plane, a 2-dimensional representation of space. If you need a refresher on that, check our coordinate plane video. Every point on your coordinate plane has a number location, kind of like coordinates on a map. A point's location along the y-axis is its y-coordinate, and its location along the x-axis is its x-coordinate. To find the slope of your line, you need to find out how much its coordinates change as the line goes along. Alright, let's take a look at 2 points along this here mountain. One point has the x-coordinate 1 and the y-coordinate 0, while the other has a x-coordinate of 3 and a y-coordinate of 2. To figure out the slope, we want to find out how the positions change exactly. The slope, or m, is equal to the amount of change in the y-coordinates divided by the amount of change in the x-coordinates. Some people call that rise over run. It helps you remember that it's a vertical change over a horizontal change. Let's try it for the mountain. Our two y values are 0 and 2, and our two x values are 1 and 3. So the slope for this mountain is equal to change in y, that is 2 minus 0, divided by the change in x, or 3 minus 1. The slope is 2 over 2, or 1. In other words, for every 1 meter this mountain goes up or down, it goes across 1 meter.
You can find the slope of any line this same way as long as you know the coordinates of any 2 points. An intercept is a point where a line hits or intercepts the x or y axis. For our mountain line, the x-intercept is 1, 0 and the y-intercept is 0, -1. Well, the y value of the x-intercept is always 0 and the x value of the y-intercept is always 0. Using the slope and one intercept, we can write an equation for that line in what's called slope-intercept form. Slope-intercept form is expressed as y equals mx plus b, where m is the slope and b is the y-intercept. So for our line, that's y equals 1 times x minus 1. You can use this formula for all sorts of things like finding more points on the line and even graphing it. For more details on that, watch Graphing Linear Equations video. Summary. To put your new knowledge into practice, try the your turn questions below. Hi, let's learn about the slope values. In this video, we are hitting the slopes literally. Slope is just a measure of how something changes vertically or up and down compared to how it changes horizontally or left and right. Simply, it's a measure of the steepness of a line. Now imagine a scenario, we are in this car. And as you can see here, on this line between 2 points, we are not moving, that means there is zero slope. But look what happens when the points move. Now we are going somewhere, the slope is going up, so we call it positive slope. And as the line gets steeper, the absolute value of the slope gets higher. Okay, now the slope is leveling up when the line is horizontal or parallel to the x-axis. It has a slope of 0. Oh, now the slope is going down. We call this a negative slope. And once again, as the line gets steeper, the absolute value of the slope increases. Okay, we're back to the zero slope. But look ahead, the slope is straight up and down running parallel with the y-axis. This slope is called undefined. Okay, that's a quick ride through the slopes. Remember, a slope is going up is positive. The slope is going down is negative. And as the line gets steeper, the absolute value of the slope gets higher. That means, if it's positive, it's really positive. And if it's negative, it's really negative. A horizontal or flat slope has zero slope. And a vertical slope is considered undefined. Don't ride your any vehicles on the undefined slopes. It's a long way to fall. Hi, let's learn about the slope formula. Okay, here is our coordinate plane, a two-dimensional representation of space. Let's take our 2 points, -3, 4 and 5, 2, and then draw our line. We can clearly see that the line is going down, that means negative slope. So what is the formula that we should use to find slope? Well, remember when we found the slope, the change in y divided by the change in x. So that's the difference between y values divided by the difference between x values. For more details on that, watch slope and y-intercept form video. Okay, so let's set up the formula using the unknown variable m as our slope. M equals y2 minus y1 divided by x2 minus x1. First, let's label our coordinates. This first coordinate will be x1 and y1, and the second coordinate will be x2 and y2. Now let's substitute our numbers. Be sure to keep everything in the proper order, y2 minus y1 on top. Remember, rise over run. Then x2 minus x1 on the bottom. So that m equals 2 minus 4 divided by 5 minus, and the x1 is negative 3. As we know, we should not write two signs or more than one sign back to back like this. We have to separate them with the bracket. So, on top we end up with negative 2, and on the bottom 5, and a negative times a negative is positive 3. So, 5 plus 3 is 8. Now, if we cancel the top and the bottom by the common factor 2, we get negative 1 over 4. Hence, our slope is negative 1 over 4. To check, let's begin at one of our points. We go down 1 on the y-axis, then right 4 on the x-axis. It falls on the line, so that's it. Our answer is correct.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the graphing linear equations using slope-intercept form. In our previous videos, we learned that graph a linear equation using 2 points. In this video, we are going to learn another method to graph linear equation. It's pretty simple. All you need to know is a couple things about your equation. Let's get started. Okay, to graph a linear equation using slope-intercept form, follow these 5 simple steps. Step 1. Make sure the linear equation is in the slope-intercept form, y equals mx plus b. Step 2. Plot the number b on the y-axis. Step 3. Convert the slope, that is m, into a fraction. Step 4. Start extending the line from b using slope or rise over run. Step 5. Connect and extend the points to make a straight line. With that in our mind, let's graph this linear equation using slope-intercept form, y equals 2x plus 1. So, let's follow those 5 steps. Step 1. Make sure the linear equation is in the slope-intercept form, y equals mx plus b. Since the given equation is already in the slope-intercept form, y equals mx plus b, that the slope m is 2 and the y-intercept b is 1. Now we move on to step 2. Plot the number b on the y-axis. In our equation, the last number is b. We know that b equals 1. So, go 1 unit up on the y-axis and mark the point. This is where our straight line will pass through the y-axis. Now step 3. Convert the slope, that is m, into a fraction. The slope of our equation m is 2. So, convert this 2 into fraction simply placing the value of 2 over 1. Because 2 is the same as 2 over 1. So now with it in the form of 2 over 1, we know that the numerator 2 is the rise or change in y. And the denominator 1 is the run or change in x. Now step 4. Start extending the line from b using slope or rise over run. Let's start at our b value. We know that the equation passes through this point. And since the change in y is 2 and the change in x is 1, which means that for every 2 units we go up along the y-axis, we go 1 unit right along the x-axis. Right, this is positive 2, so we are going to go in the positive direction of the y-axis 2 units to here. Then we are going to go in the positive direction along the x-axis 1 unit because the change in x is 1. And then we plot a new point and we can continue to build off of each point. In this case, our new point by repeating that slope again. So we are going to go up 2 for y and then over 1 for x. And if you want to plot some points on the other side, on the left side of that y-intercept, that to just repeat the process in reverse. In this case, going to the left 1 unit and then down 2 and plotting another point. So now we have all these points and you can really see that our line is starting to take shape. We can draw a line through. So step 5. Connect and extend the points to make a straight line. And now we have successfully graphed our linear equation. Y equals 2x plus 1. Now let's graph this one using slope-intercept form. 3x plus 2y equals negative 4. So step 1. Make sure the linear equation is in the slope-intercept form. Y equals mx plus b. As you can see here, the given equation is not in the slope-intercept form like y equals mx plus b. So, to make it like slope-intercept form, simply solve for y, which means isolate the y on the left hand side of the equal sign. That's it. If you need a refresher on that, watch solving linear equations with one variable. Okay, in order to isolate the y term on the left of the equal sign, bring this 3x to the other side. By doing so, we get 2y equals. Now usually we write whatever already on the right hand side first. But here we need to make the given equation to slope-intercept form in which x term comes first. So that first write negative 3x. Why negative? Since we brought positive 3x from left to right. Then minus 4. Here what we want is our equation like y on its own on the left of the equal sign. But the multiplication of 2 is in the way of that. So to remove it, do the opposite. In this case, divided by 2. To keep the balance, just do it on both sides. So 2 divided by 2 is 1 and that 1 times y is just y. That's just solving for y. Okay, we cannot cancel this denominator 2 by any of the numerators because we don't have license to cancel. I mean, there is no multiplication sign between them. Moreover, when you have an expression on the top joined with plus or minus divided by something, we can also write this as negative 3x over 2 minus 4 over 2. Because what's happening here is, I have a first term divided by 2 and a second term divided by 2. And I know that I can break them apart because if you were to go this with direction and go backwards, like if I just cover all this up and said, hey, what is this equal? You would try to subtract the fractions, right? You would say, well, there is a common denominator, so I need to have a common denominator of 2, and then I'm just gonna write the numerator as it is, which is what I have done here. So breaking things apart is exactly the same as going and combining fractions going this way. So that should convince you that this is legal, right? And so what we end up getting for y is what? We cannot divide 3 by 2, so leave it as it is. And dividing the negative 4 by 2 gives you negative 2. So this is what we call the slope-intercept form of the equation of a line. And it actually makes it much easier to graph using the version of it. And in general, the slope-intercept form is the following: y equals mx plus b. Notice right away that it matches up exactly with what we have here. You have something for, in this particular case, m, that is slope was equal to negative 3 over 2. And in this particular case, b, that is the y-intercept, was equal to -2. Okay, we have converted the given equation to slope-intercept form. So we move on to step 2. Plot the number b on the y-axis. We know that b is -2. So from the origin, go 2 units down on the y-axis and mark the point. This is where our straight line will pass through the y-axis. Now step 3. Convert the slope m into a fraction. The slope of our equation m is -3/2, which is already a fraction, so we don't have to convert it. So let's move on to step 4. Start extending the line from b using slope or rise over run. Okay, now from y-intercept b, we want to find the slope. Since the change in y is -3 and the change in x is 2, which means that for every 3 units we go down along the y-axis, we go 2 units right along the x-axis. Here, a very common mistake is that a lot of people start from the center and go 3 down over 2. But no, we already put our starting point here. So since we already put that, that is where we start counting from. Okay, because this is -3, we are going to go in the negative direction of the y-axis 3 units to here. Then we are going to go in the positive direction along the x-axis 2 units because the change in x is 2. And then we plot a new point and we can continue to build off of each point. In this case, our new point by repeating that slope again. So we are going to go down 3 for y and then over 2 for x. And if we want to plot some points on the other side on the left side of that y-intercept, that to just repeat this process in reverse. In this case, going to the left 2 units and then up 3. And plotting another point. So now we have all these points and you can really see that our line is starting to take shape. We can draw a line through. So step 5. Connect and extend the points to make a straight line. And now we have successfully graphed our linear equation 3x plus 2y equals -4.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about the inequalities. As well as the familiar equal sign, it is also very useful to show if something is not equal to, greater than or less than. These are the important signs to know. When two values are equal, we use the equal sign. Example, 3 plus 2 is equal to 5. When two values are definitely not equal, we use the not equal to sign. Example, 3 plus 2 is not equal to 8. But when one value is smaller than another, we can use a less than sign. Example, 4 is less than 7. And when one value is bigger than another, we can use a greater than sign. Example, 9 is greater than 3. To remember which way around the less than and greater than signs go, just remember the less than sign looks like a letter L, isn't it? So you can easily remember the letter of the first letter of less than sign. Since there are only two signs in total, less than sign is this and the greater than sign is that. Example, 11 is greater than 7, or the other way around, 7 is less than 11. It is that simple. Sometimes you know that a value is smaller but may also be equal to. Example, the maximum weight allowed inside an elevator is 500 kg. So what is the total weight of the people inside an elevator? It could be 500 kg or it could be less than 500 kg. So until we measure it, all we can say is less than or equal to 500 kg.
To show this, we add an extra line at the bottom of the less than or greater than symbol like this. The less than or equal to sign, the greater than or equal to sign.
Here is a summary of all the symbols. 2 plus 2 is equal to 4. 2 plus 2 is not equal to 5. 7 is greater than 2. 5 is less than 9. Candies are greater than or equal to 1. Trees are less than or equal to 4. And we call things like that inequalities because they are not equal. Then why would you use these two? Because there are things you don't know exactly but can still say something about. So we have ways of saying what you do know which may be useful. Here is an example. Sam had 7 candies and ate some. How many does he know? Answer. He must have less than 7. If Sam still has some candies, we can also say he has greater than 0 candies. I mean, candies greater than 0. But if we thought Sam could have ate all his candies, we would say candies greater than or equal to 0. We can sometimes say 2 or more things on the one line. Example. In school days in US, the school zone speed limit of your vehicle, let's say the speed limit of your car is 25 miles per hour. So how fast that car went? Answer. Something greater than 0 mile per hour and less than 25 miles per hour, but not 0 mile per hour and 25 miles per hour. This can be written down in just one line. 0 mile per hour less than what car speed is less than 25 miles per hour. That says that 0 mile per hour is less than what car speed is. In other words, what car speed is greater than 0 mile per hour and what car speed is also less than 25 miles per hour. Then most importantly, notice that greater than was flip over to less than when we put it before what car speed is. And always make sure the less than sign looks like a letter L. Here is another example using greater than or equal to and less than or equal to. Let's say Fatima went to the doctor because she was not feeling well. The waiting time to see the doctor is greater than 4 minutes but less than 10 minutes. How long will she be waiting? Answer. Something greater than or possibly equal to 4 minutes and less than or possibly equal to 10 minutes. Fatima waits greater than or equal to 4 minutes. Fatima waits less than or equal to 10 minutes. This can be written down in just one line. 4 minutes less than or equal to Fatima waits less than or equal to 10 minutes. One more example. What is x plus 3 when we know that x is greater than 11? Start with if x greater than 11, then x plus 3 greater than 14. Imagine that x is the number of people at your social media group. If there are more than 11 people at your group and 3 more arrive, then there must be more than 14 people at your social media group now.
Summary. To put your new knowledge into practice, try the your turn questions below.
Hi, let's learn about solving the inequalities. Sometimes we need to solve inequalities like these. Solving inequalities is very like solving equations. We do most of the same things. Like solving an equation, here our aim is to have isolate the x or whatever the variable is on the left of the inequality sign. Something like x greater than 5 or y less than or equal to 13. That means we solved. However, there are a couple of important differences, so pay close attention. Follow the same 3 steps when solving inequalities that you follow when solving equations. and add a fourth step. Step 1. Simplify each side of the inequality using the order of operations. It's like removing brackets using distributive law and combining like terms. Simplifying each side of the inequality is a two-step process. First, simplify the left-hand side. Next, simplify the right-hand side. Step 2. Isolate all the variable terms to one side of the inequality and move all the numbers to the other side. Step 3. Multiply or divide both sides of the inequality by the same number. Now here is the key difference. If you multiply or divide by a negative number or swapping left and right hand sides, reverse the direction of the inequality. Like less than becomes greater than becomes less than or equal to becomes greater than or equal to, and greater than or equal to becomes less than or equal to. Why? Well, just look at the number line. For example, from 3 to 7 is an increase, but from -3 to -7 is a decrease. See how the inequality sign reverses from less than to greater than. Step 4. Graph the answer on the number line. For example, we can graph the inequality, say x greater than 5 on the number line this way. Circle 5 on the number line and shade the number line to the right of 5. Since the inequality says that x is greater than 5. See, the blue line starts at 5 and points upward into infinity. So all the numbers greater than 5 make the inequality x greater than 5 true. If x were greater than or equal to 5, we would just fill in the circle. See? Now according to this, all the numbers greater than or equal to 5 make the inequality x greater than or equal to 5 true. Now let's start solving the easiest, x plus 2 greater than 12. Here there is no need for step 1, I mean no need for simplifying on both sides. There are no like terms on this side and there are no like terms on that side. So let's move on to the step 2. Our aim is to have isolate the variable x on the left hand side of the inequality sign. But the plus 2 is in the way of that. So let's move this plus 2 to that side. Consequently we get x greater than, and here we have to write whatever already on this side first, that is 12. And if you bring this plus 2 to that side, it becomes minus 2. Therefore, x greater than 10. Now, let's graph the answer on the number line. Circle the number 10 on the number line. Circling 10 indicates that 10 is not included in the graph. Then shade the number line to the right of the number 10, since the inequality says that x is greater than 10. So all the numbers greater than 10 will make the given inequality x plus 2 greater than 12 true. We could check whether we solve an inequality correctly by following these simple steps. First, change the inequality into an equation. X plus 2 greater than 12 becomes x plus 2 equals 12. Step 2. Substitute the answer for the variable x. Here, our answer is 10. So substitute the value 10 for x. We get 10 plus 2 equals 12. This is a true sentence. So the step 2 says that move further. Step 3. Substitute 0 in the inequality to check the direction of the inequality. Let's check the direction of the inequality by substituting 0 for x. 0 plus 2 greater than 12. This is not true. So 0 is not part of the solution set. If it were, the answer would be x less than 10. But because 0 is not part of the solution, the correct answer is x greater than 10. Yes, we were correct. Let's try another example. -9 less than or equal to -3y. Or we can say -9 less than or equal to -3 multiplied by y. Here there is no need for step 1, no brackets and no need to combine like terms. So we move on to the next step. Well, here our aim is to have isolate the variable y on the left hand side of the inequality sign. But y is on the right. No matter, just swap sides but reverse the sign, so it still points at the correct value. And when I do that, I'm gonna put a big star here because hopefully you know the rule that's coming. We get negative 3y, and since we swap sides, this less than or equal to sign becomes greater than or equal to negative 9. Okay, now what we want is an answer like y on its own on the left of the inequality sign. But the multiplication of negative 3 is in the way of that. To remove it, do the opposite. In this case, divided by negative 3. Because negative 3 divided by negative 3 equals 1. So, let us have a go at dividing negative 3 on both sides. And when I do that, I'm gonna put a big star here because hopefully you know the rule that's coming. Negative 3 divided by negative 3 is 1, and 1 times y is just y. Negative 9 divided by negative 3 is just 3. But I did something really important here. I divided by a negative number. And whenever you do that, remember to reverse the direction of the inequality. So it was a greater than or equal to sign, but because I divided by negative 3, it became a less than or equal to sign. We get y less than or equal to 3. Now let's graph the answer on the number line. Circle 3 on the number line and shade the circle. Shading indicates that 3 is included in the graph. Then shade the number line to the left of 3, since the inequality says that y is less than 3. So all the numbers less than or equal to 3 make the given inequality true.
Summary. To put your new knowledge into practice, try the your turn questions below.
Now, let's solve this inequality. I repeat, generally when we are solving inequality, our aim is to have isolate the variable on the left hand side of the inequality sign. So, step 1. Simplify each side of the inequality, which means like removing brackets using distributive law, combining like terms and all. So the first thing I always want to do if I see it's a distributive, that negative 2 outside of a bracket means I need to distribute it. So negative 2 times x is negative 2x. Negative 2 times positive 3 is negative 6. Is greater than or equal to 10, alright. There are no like terms on the left side and there are no like terms on the right side. Step 2. Isolate all the variable terms on one side and move all the numbers on other side. Here I can see the only one variable term, that is negative 2x. So let's hold the negative 2x and bring this minus 6 to that side. We get negative 2x greater than or equal to, here first write whatever already on this side, that is 10. And if we bring the minus 6 to that side, it becomes plus 6. So we have negative 2x greater than or equal to 16. Step 3. Here what we want is an answer like x on its own on the left of the inequality sign. But the multiplication of negative 2 is in the way of that. To remove it, do the opposite. In this case, divided by negative 2. Just do it on both sides. And when I do that, I'm gonna put a big star here because hopefully you know the rule that's coming. Negative 2 divided by negative 2 is 1. And 1 times x is just x. 16 divided by negative 2 is negative 8. But I did something really important here. I divided by a negative number. And whenever you do that, that inequality sign has to flip the other way. So it was a greater than or equal to sign, but because I divided by negative 2, it became a less than or equal to sign. So my solution is x less than or equal to negative 8. Now I move on to the step 4. graph the answer on the number line. So when I go to graph that, circle -8 on the number line and shade the circle. Shading indicates that -8 is included in the graph. Then shade the number line to the left of -8. Since the inequality says that x is less than -8, so all the numbers less than or equal to -8 make the given inequality true. Let's solve another example. 2y minus 5y plus 4 less than 13. Step 1. Simplify on both sides. There are no brackets on both sides, but we could combine like terms here. On the left hand side, we could combine 2y and -5y. We get -3y and write the rest exactly as it is. Step 2. Let's isolate the y term on the left side of the inequality and bring this plus 4 to that side. By doing so, we get -3y less than and copy the 13. Then if I bring this plus 4 to that side, it becomes -4. So -3y less than 9. Now I move on to the step 3. Multiply or divide both sides of the inequality by the same number. Here, what we want is an answer like y on its own on the left of the inequality sign. But the multiplication of -3 is in the way of that. To remove it, do the opposite. In this case, divided by -3. Just do it on both sides. And when I do that, I'm gonna put a big star here because hopefully you know the rule that's coming. -3 divided by -3 is 1 and 1 times y is y. 9 divided by -3 is -3. But I did something really important here. I divided by a negative number. And whenever you do that, you must reverse the direction of the inequality. So it was a less than sign, but because I divided by a -3, it became a greater than sign. So my solution is y is greater than -3. Step 4. Graph the answer on the number line. Circle the number -3 on the number line. Circling -3 indicates that it is not included in the graph. Then shade the number line to the right of the -3 since the inequality says that y is greater than -3. So all the numbers greater than -3 will make the given inequality true. The last one. -1/2 times x minus 10 greater than or equal to 7. Step 1. Simplify each side of the inequality. So the first thing I always want to do, if I see it is distribute. That -1/2 outside of a bracket means I need to distribute it. -1/2 times x is -x/2. Because by multiplying the numerators, -1 times x is -x. Then -1/2 times -10 is +10/2. Because again multiplying the numerators, -1 times -10 is +10, is greater than or equal to 7. Now let's cancel the 10 and the 2 by the common factor 2. We get -x/2 plus 5 greater than or equal to 7. Step 2. Isolate the variable terms. So let's hold this x term and bring this plus 5 to that side. By doing so, we get -x/2 greater than or equal to 7 minus 5. So we have -x/2 greater than or equal to 2. Now step 3. Multiply or divide both sides of the inequality by the same number. Here, what we want is an answer like x on its own on the left of the inequality sign. But the division of -2 is in the way of that. To remove it, do the opposite. In this case, multiply by -2. Just do it on both sides. And when I do that, I'm gonna put a big star here because the rule is coming. Hey, we could cancel the negatives because a negative times a negative is a positive. Then we can cancel that denominator 2 and the numerator 2 by the common factor 2. We get 1 times x, which is just x. Then 2 multiplied by negative 2 is negative 4. But I did something really important here. I multiply by a negative number. And whenever you do that, you must reverse the direction of the inequality. So it was a greater than or equal to sign, but because I multiply by negative 2, it became a less than or equal to sign. So my solution is x less than or equal to negative 4. Now step 4. Graph the answer on the number line. Circle negative 4 on the number line and shade the circle. Shading indicates that negative 4 is included in the graph. Then shade the number line to the left of negative 4 since the inequality says that x is less than negative 4. So all the numbers less than or equal to negative 4 make the given inequality true. How do we solve something with two inequalities at once? First, let us clear out the divided by 4 by multiplying each part by 4. Because we are multiplying by a positive number, the inequalities don't change. We get negative 8 less than 6 minus 2x less than or equal to 12. Now subtract 6 from each part because it gets us closer to isolating the variable x term. By doing so, we get negative 8 minus 6 is negative 14. And in this part, if we cancel plus 6 and minus 6, we have negative 2x. Then 12 minus 6 is 6. Now to fully isolate the x, we can divide each part by negative 2. And when I do that, I'm gonna put a big star here because hopefully you know the rule that's coming. Here, negative 14 divided by negative 2 is 7. And negative 2x divided by negative 2 is 1x, which is just x. Then 6 divided by negative 2 is negative 3. Because we were divided by a negative number, the inequalities change direction. This less than sign becomes greater than. And this less than or equal to sign becomes greater than or equal to. So our solution is 7 greater than x greater than or equal to negative 3. But to be neat, it is better to have the smaller number on the left, larger on the right. So let us swap them over and make sure the inequalities point correctly. So we have negative 3 less than or equal to x less than 7. Now let's graph the answer on the number line. Circle negative 3 and 7 on the number line. Then shade the circle negative 3 because there is a line at the bottom of the less than symbol. After that, shade the number line between negative 3 and 7. So all the numbers greater than or equal to negative 3 and less than 7 will make the given inequality true. Here is a tricky example. Ax less than 4a. It seems easy just to divide both sides by a, which gives us x less than 4. But wait, if a is negative, we need to reverse the inequality like this, x greater than 4. But we don't know if a is positive or negative. So we can't answer this one.